And so as a result, they can even charge fees and things like this or freeze your funds. And this is all true with regards to bridges at the moment as well. On the other hand, we have interfaces. And interfaces are protocols which translate or represent one semantics of ordering, compute, storage, and so on of an underlying machine. They are just code. They are freely copied. They are very different to intermediaries, right? They are, you do not have to interact with a specific counterparty. As long as you interact, or as long as you sort of adhere to this interface, you can connect and talk with anyone else that adheres to the same interface. In the real world, one of the best examples here is TCP/IP. And here sort of the distinction becomes very obvious, right? That in order to connect to the internet, not all of us have to talk to the same Oracle server run somewhere in New York. As long as you implement TCP/IP, and there are many implementations in many different languages, you can handwrite your own. Honestly, TCP/IP is not that complicated. If you're dedicated and have like 2 weeks time, you can probably implement your own TCP/IP stack in the language of your choice. You can talk to anyone else that implements this, right? And it's a very different model. It's a model where every central server can go away, and it still works that 2 people in this room use the interface to talk to each other. This is very different to the intermediary case, where if the intermediary goes away, you cannot use that service anymore. Here, this is just code. You can change it, you can modify it, you can do whatever you want with it. You can re-implement this from scratch. It doesn't matter. And I just want to stress this because the ANOMA protocol is a protocol for declarative intent, imperative ordering, compute, and storage semantics of underlying machines. It is just code. There are full specs for this. You're free to copy this. You're free to modify this. If you want to implement this in many different languages on many different virtual machines, please go ahead. This is to say that there's no ANOMA chain. There's no ANOMA chain to which you must send your intents in order for you to leverage ANOMA. You can just use ANOMA deployed on Ethereum without ever interacting with any specific ANOMA chain. You're just interacting with the interface. You're adhering to the interface standard, right? And yeah, sadly, I think this point really, interfaces versus intermediaries, really gets overlooked quite a bit in the current world, where I think a lot of people assume they're interacting with an interface, whereas in reality they're interacting with an intermediary. So whenever you use anything on chain, actually make sure which one of these 2 categories you fall into. Intermediaries are fine, you should just know about it. Yeah, so ANOMA, it's a universal intent machine for Ethereum. This is really sort of the simplest way to say this. ANOMA does something that just adds extra capabilities to what's currently possible in Ethereum. It provides a generalized abstractions for universal or generalized intents. Yeah, so what does this actually mean? It means that builders can write dApps in terms of intents instead of transactions or execution traces. And here, this is a very important difference, where currently everyone is writing applications, or users interacting with Ethereum are interacting at the transaction level, right? Like, as a user, you're currently signing over a specific execution trace. You don't actually sign over a specific state change, you sign over a set of opcodes that can modify the state. Incidentally, this is where a lot of the MEV comes from, that the fact that if I have an execution trace that I've signed over and someone else has an execution trace that they signed over, depending on how you interleave them, you get to different state outcomes, right? Like, this is sort of fundamentally, they are not pure in that sense. With intents, you are writing in terms of state updates. You're writing, I currently have state B and I'd like state, I currently have state A and I'd like state B. And the system can figure out sort of, is there something to actually like provide the inverse, or B to A, or is there maybe 500 people that sort of, if you take all 500 intents combined, then sort of this balances out. So intents really, as a builder here, you can start writing your applications in terms of partial state transitions that may or may not get sort of solved for, rather than fully fledged state transitions that are immediately executable on chain. Yes, so a lot of people think about intents and they think limit orders. And this is technically correct. Limit orders are a very specific kind of an intent, right? But here, what we're really talking about with ANOMA and the ANOMA resource machine, it's ANOMA implements general intents. Whatever you can write down in code, whatever state you want to express, you can express it using ANOMA. You're not constrained to any kind of specific intent. So you can use sort of these generalized intents to build limit orders, sure, but you can also use this to decentralize something like a Gitcoin DAO, where individual users end up having individual votes. We collect 500 of them, then those 500 intents get combined into a fully fledged state transition that is then actually executed on Ethereum. Interesting enough, intents also just generalize rollups, because when you think of what a rollup does, right? A rollup is you have a state transition from A to B, someone else has B to C, and so on. And then the rollup collapses the entire thing into A to D or whatever. Intents just generalize this model. Yes, and this is really important actually. Intents and dApps written sort of adhering to the ANOMA protocol specification can be ordered, solved, and settled on Ethereum. With ANOMA, you get an entire P2P stack in order to enable, for example, decentralized counterparty discovery and distributed solving. But fundamentally, if you care about the security model of Ethereum, go ahead. You can just settle to Ethereum here. Yeah, so in summary, ANOMA is a universal intent machine for Ethereum. Intents and dApps written with ANOMA can be ordered, solved, and settled on Ethereum. And interesting enough, if you're really into distributed systems, come find me later and we can chat about sort of generalized sequencing. But the consensus behind ANOMA is called Typhon, and it generalizes shared sequencing, which enables you to, now that you have intents, you can not only settle on Ethereum main chain, you can also sort of in the intent specify what rollup or what specific security zone you care about. Maybe you want to specify that you want to settle on Ethereum main chain because this is a security model you care about. Maybe you want to say that, well, I want to be on an EVM rollup, or I want to be on even a non-EVM rollup. It doesn't actually matter here, or something like an eigenlayer AVS. So really, the pick is yours. This is really important to understand. Like, the intent machine here, it's an abstraction. It's a high level of abstraction that makes it possible to build applications that were not possible to be built before, right? Like, it is something on top. It is not something to try to replace existing infrastructure. It is just to make the developer experience and the user experiences more expressive. Oh, actually, what's my time? Great. So yeah, let's talk a little bit about intent-centric dApps on Ethereum. And why use ANOMA to build dApps here, actually? What affordances are provided? You get permissionless infrastructure, as in you do not have to talk to a specific counterparty in order to be able to use the system. You can just gossip your intent to 2 of your friends, because those are the only people you trust, so you can gossip them multicast to the rest of the world. This is really up to you. The topology of ANOMA is not defined in the architecture. And this is, I think, something that most protocol architects are currently doing wrong to a large extent, that it is very difficult, or it's impossible within an architecture to define the actual deployed topology of the system, right? The topology of the deployed system, as in which node connects to whom, is purely dependent on user and operator behavior, as in who chooses to interact with whom. And ANOMA goes to great length to make the architecture completely topology agnostic, so that the actual users, the actual economic flows can form the topology that they care about. For example, you can build a topology that is optimized for latency. And here one example is that if 3 people here want to sort of locally trade some, I don't know, ETH or Bitcoin or something, like genuinely intense, the obvious thing to do is that we locally connect over fiber optics with each other to order and solve these intents, and then settle them on Ethereum if we all care about the Ethereum security model, right? Like, it makes no sense that each of us talks to a servers halfway across the world in order to do the counterparty discovery of Bitcoin. I do not have to specify on which specific dApp or exchange I want to do this. I just go, this is the state transition I would like to achieve. And then other people may have completely different intents. They may be wanting to trade in a different security model or a different setup. But those intents can still compose, because in the end, intents are just sort of declarative models of like, I have state A and I'd like state B, and as long as someone else has B to A, or something like someone else has B to C, and then there's C to A, you get this intent level composability. The other nice thing is you get intent machine composability. And what that means is, rather than treating every single rollup in the ecosystem as a separate system, you can just interact with the intent machine and say, well, I would like to settle to, I would like the security of this specific rollup. So rather than treating, you can treat a network of distributed machine or distributed systems as a single intent machine, rather than as many different disjoint intent machines. You also get information flow control. And really this comes to the point that, and I think most people don't realize this yet, but so in the current world of blockchains, we all work with a large piece of globally mutable state that is readable and writable by everyone that sits in the middle of the system, right? As soon as we want to have anything with ZK, state moves to edge devices. As in, state will move to your local edge device. And you as a user end up having the choice here, what kind of information do I actually want to reveal? You can reveal everything, you can reveal only what you want to do but not who you are, right? Like information flow control is fundamentally going to be important because it maps better the model of where the state is actually going to live in these systems. As in state mostly lives on local end devices rather than sort of in the middle of the network where everyone has to sync this. This is also way better from a scalability perspective because rather than having all state live in the middle and like now all nodes have to sync all state, we can have commitments to that state and the actual state, the underlying data, never has to be shipped across the network. It just resides on edge devices like your phone, your laptop, whatever, and you choose what actually to publish into the rest of the network. And you get this idea of heterogeneous trust. And I think this is going to be actually very important because trust is very subjective. Not everyone will want something that's globally decentralized, right? Like my parents, for example, they want something that's locally secured. They want local sovereignty because they trust their local community. If you live in, I don't know, maybe Argentina or somewhere like this, you may actually really not trust your local security. In that case, it's very valid that you want to make the choice to go into the globally decentralized thing, right? But the important thing is with ANOMA, we don't pick the security model. Sort of as a user, you can individually pick, do I care about local sovereignty? Do I want to use a globally decentralized system? The architecture does not constrain the topology here of what is possible. Yeah, so let's go through, I think, 4 examples of what kind of novel dApps can you build using ANOMA on Ethereum. Great. So public signal. This is effectively the inverse, and this is something I'd very much like to see. This is the inverse of Kickstarter, where rather than being supply-side driven, right, Kickstarter is very supply-side driven. Someone goes, I think a lot of people will like this idea, then they publish, they sort of supply this idea into the market, and then if enough people come together to actually have demand, then this may happen. Public signal is the inverse of this, where a lot of individuals can start signaling with intents using cryptographically signed intents, the idea that they would like X to be done. And now we can start sort of seeing what is their demand for, and rather than sort of supplying something and hoping that there will be demand, we can rather listen to the sort of the intent gossip and go, oh, there clearly is some demand here. Now let me try to build this. And the nice thing is, for example, if you had something where you need at least, I don't know, 10 ETH or something. So like 100 people come together, everyone provides some ETH. And so if you publish this as demand, as soon as someone is capable of supplying the other side, they can take those 100 intents together, create their own intent that provides the supply side, and then settle this immediately and make this executable on chain. This is sort of the thing I'm most excited about at Scale for Your Money. It's the capability to effectively issue mutual credit lines. So rather than rely on centrally issued currencies, we can use Scale for Your Money that I issue my own currency and only my like social network will trust my currency, right? But sort of instead of all having to route via the central currency, we each issue our own, and then I can do credit clearing with people that I trust. And sort of over time, you can start expanding this network that if I'm trying to transact with someone that I'm not directly connected to, but there's a hop along some path in my social graph, we can still transact. And I think this is sort of a very cool idea that is especially useful for smaller economies, because it allows smaller economies to sort of like really bootstrap their asset without having to rely on sort of everyone has to route via USD. You can directly route via your own currency. I mostly think about this in the case of Switzerland, where at Switzerland you can issue local currencies, as in like there's a cooperative that there's mutual credit clearing in Weir or something, Weir? I forgot the city name. But so there are some attempts, but I think really ANOMA provides here very scalable infrastructure using intents to actually enable scale-free money at scale. You can build multi-chat. It's an actually decentralized version of Discord because, again, intents are arbitrary. They may be financial in nature. They may be carrying financial assets. They may be carrying ETH. But they may also be just carrying data. There's really no distinction here between, I think this is actually an important point regardless, there's no distinction between like information and assets. I think in the digital world, a lot of these things are collapsing onto each other, where using intents, you can just build a very cool chat application that, where sort of the topology of the network is defined by who's actually talking to whom, and who wants to trust each other with their data. And then you can use build something like a promise graph, which is simply a system for organizations to not be bound by specific team boundaries, but to rather like let the organizational setup reflect the actual work being done. And this is something we're using internally, which is very cool. So we are dog-fooding the promise graph to build ANOMA, which is nice. Yeah, if you are interested on like jamming on some of these ideas, there you go. It's a QR code to research.anoma.net. So, let me see. All right, great on time. All right, TLDR. VMs and IAMs aren't compatible, aren't competitive. They are just a fundamentally different layer of abstraction. They allow you to do something else. You should care about interfaces, not intermediaries. Using intermediaries is fine. You should just be very aware that they add into your trust model. They're not just an interface. Yeah, what does a universal intent machine mean for Ethereum? It means that you can build intent-centric dApps. You get a standard for intents. And most importantly, you can actually settle on Ethereum. Again, on the affordances, you get permissionless infrastructure. You get intent and machine-level composability. You get a large amount of information flow control, which I think is going to unlock the next wave of applications, actually. And you get this fundamental idea of heterogeneous trust. Yeah, and then we spoke about some ideas for novel dApps on Ethereum. There. If you have 2 hours or 3 hours, maybe, ideally your entire flight back, check out this post that my co-founder Chris wrote on ANOMA as a universal intent machine for Ethereum. It is dense, but it's very worthwhile because it explains all of ANOMA in a very understandable way. So if I went through some of these concepts way too fast right now, this also has all the links to sort of the underlying background material with regards to cryptography as well as the distributed systems part. So yeah, please check it out. Yeah, this was it. Thank you very much.
All right. Thank you very much, Alex. I mean, Adrian. We have, I think, 2 Alexes, and I got his name mixed up. Adrian. So what's going to be going on today here in track 1? So you're going to be hearing a lot of talk about intents. We also have a talk on ZK rollups, but most of the talks in here are intents today. And all the speakers that you see here talking about intents today will be all joining us for a panel here at noon on this stage to speak about intents. So we'll have lots of presentations, and then we'll have a good discussion at noon. So next up, Munir, is it?
Okay, yeah.
Yeah, is it Munir Benchmade?
Exactly.
Okay, great. So he's going to be diving a little bit deeper into intents, the gold standard for transacting on-chain, setting the bar for efficiency and user experience. He will cover the trade-offs, particularly considering decentralization. So, yeah, give it up for Munir.
Hey guys, good morning everyone. Hope Dubai was treating you well. It's been an interesting week for the first time for me. But yeah, so far so good. So I'm Munir, I'm founder of Paraswap and Portugus since recently. Paraswap, we are a decentralized exchange aggregator running on 9 EVM blockchains since 2019. And Portugus is a new protocol that I'd like to talk to you about today. And I guess you had a great talk from Adrian about intents. So I would like also to try on my side to explain intents the simplest possible way to also convince everyone that intents are really the future. So when you guys go to a coffee shop, you can either ask for an espresso and precise the recipe, the way the coffee will be made, and give all instructions to the barista, which is fine. I mean, it happens. It entails various steps, and maybe you're an expert in coffee or like a very, let's say, coffee guru, which works, but the vast majority of people will just express an intent. They would say just, I want a normal coffee, and I think even if you are a coffee guru, well, most of the time you're in a hurry or you just want your coffee, and you trust that the barista will do the right thing, and you just ask for the coffee, and the barista will do the magic in providing you the best possible coffee that you will enjoy. But another example that I like is when going from point A to point B. So for instance, you want to go to a party in Dubai, and there are various options to get to the party. So you get a car, you need to make sure you take the right road, you respect the speed limits, and the traffic lights, and all of that, which you can do. It's a lot of steps. You get more control, of course, when you are in your car. Sorry. But in fact, our objective is to get to the party and not the way you are getting to the party. So why don't you just get an Uber, express an intent, I'm going to the party, to this address, and just push a button and it will be done for you. The magic will be done by your driver and the service that's running on the back, on behind the scenes, and you get to enjoy your party. You don't need to worry about how the traffic is working and how Dubai traffic is working and the flood and all of those things. But in trading, in DeFi, in trading in general, this is how trading used to work forever, even before DeFi. It's just that the infrastructure wasn't there. But if you go to Binance or Coinbase, well, you don't tell Binance how to execute a microservice or how to run a DB. You just push a button and say, I'm selling that token for that token, or I'm creating a limit order, and the trading engine is going to do the work for you. And this is now happening in DeFi as well, where you can either go to a counterparty, that's like a Paraswap today, or the vast majority of DEX UIs, where you need to load your wallet, you need to make sure you have enough gas, you need to make sure that the gas price hasn't changed and track all of that. Or you can just push a button and express an intent. You're selling token A for token B, you're okay with the price, sign a message, and it's done for you the most optimal way. Obviously, we'll get into more details. But that's the bottom line, is you don't need to worry about the magic behind the scenes. You just need to worry about your trade being executed. And that's, I guess, for the vast majority of this world population, that they won't be degens and DeFi natives. But also, if you're a degen, your goal is to really acquire that token in order to ape in into another protocol or speculate on that token. Your goal is not really the execution details. So I think this works for everyone, not just for I would say, the average Joe. So benefits, obviously, I mean, I guess many of you have known, and you've seen also the Adrian talk was really amazing. But we get, at the same time, an improved user experience. That's what we aim for, to also get DeFi into the masses. We abstract all the complexities like gas, protection against MEV, and all of that. And we get to also simplify new use cases, like obviously swaps, but also limit orders, DCA, yield optimization, you name it. So now I'd like to talk about Portugus and our take on sign a message and a bunch of solvers behind the scenes competing for the user and having the right, the winner has the right to execute the trade on behalf of the user. Problem with this architecture, it's working fine, it's great. It processed billions of dollars so far, so it's really working. We have a real product market fit. But the problem is that we still rely on a centralized middleman. That's like a Google server, AWS, and all of that. It's working. The user is still self-sovereign. So we're still in the DeFi realm at its core. But the problem is that it's not unstoppable. It's not non-censorship resistance. It still doesn't fit or check all the boxes in decentralization. I think we can do better than that. And this is where we are introducing what we call here a decentralized layer. It's one way of keeping an abstraction, of not giving it yet an architecture. It's kind of an intent, if you would, on architecture terms. There are various possibilities like app chains, new layers, or like chain link type of networks. But bottom line, the idea is that there is no longer a hard reliance on a centralized server. It's a new neutral network where users can submit their intents, and that neutral network, or that what you call DL here, will create auctions, and solvers will compete with the DL. And what we get here is, well, decentralization, like this is a neutral, decentralized network, but also provability and we avoid censorship resistance. I mean, we have, censorship resistance, unlike if we are running a centralized party, and the platform, the system becomes unstoppable. This is really what we want. But obviously, as pragmatists, we think that, well, we try to improve user experience and to improve resilience. But if we introduce in, let's say, a new complex network that end users have to deal with, let's say an app chain where users have to pay gas again, well, we defy the purpose of user experience. So this is where we think, out of pragmatism, we need to still keep those centralized middlemen, but they will be this time optional. So you don't need to use them, but you use them out of convenience. Let's say, for instance, you are QuickSwap or Camelot. You want to provide the best possible experience to your users. So you provide them with, you run your own layer, you abstract all the complexity behind the scenes, you provide them the best possible experience. But at the same time, they can bypass you if they want to. If you are a sophisticated user or a high frequency trader, you can plug in directly to the DL. But for the average Joe, they will still go to the relayer. But what they get to here is auditability and provability on after the facts. Like if my trade wasn't executed to the best possible way, I can still go back in time and check and audit and make sure that, well, it's indeed happened as expected and the best possible execution really indeed happened. So also, yes, been running Parasoft for 5 years. I think there is the idealistic world that we want to see, but I think what's best we can do for the ecosystem is to provide iterative improvements. Like we deliver products that has the core features that users want, and users want nice UX, users want protection against MEV, they want the best possible execution. So this is where we are breaking this down into 5 steps, where a step 1 and 2 will achieve a similar state to existing product, still with the centralized middleman, but with an iterative improvement. That's not enough, of course, so this is where we're aiming to launch this DL and breaking down the research into multiple phases over time. Doesn't matter how long it takes, but what matters is the learnings we get from end users and the product that we put in the hands of users. So the first stage we call Doric. It's fancy names, came from one of my colleagues who likes the Roman era, and that will be, well, we have a product that abstracts MEV, gas, on layer 2s, it's faster than usual products. And stage 2, where this is where we introduce a network of solvers. And in stage 3, this is where we introduce a new decentralized layer that's kind of, I would say, similar to more or less to Anoma, but it's very, very oriented into trading or transactions instead of a very general purpose, which is great also. It's a great, great concept that we can obviously learn from. But then moving forward, since it's a decentralized layer, doesn't matter what its nature, but to be decentralized means also an incentive system, a self-sustainability. So this is where we are working also on new fee models. There are various options. There are options we can cherry pick from traditional finance, funny speaking, but they can work very well if executed in a transparent way, in an efficient way, like payment for order flow, where, well, it's still a platform for trading. They monetize through fees, and that's also the path we're taking. Obviously, we're exploring other things because it's still a new system, like subscription models, although I tend to think that well, fees are the way to go for exchanges and exchange platforms or protocols, but TBD, also that's done in purpose. If let's not do it now, let's do it later, and let's keep the research and iteration and feedback, especially from users, in order to get there. And the last step, the end game, is to deliver a fully decentralized network, self-sustaining, using the architecture that we are looking at right now. There are also various questions, open questions like privacy, for instance, and how to achieve privacy and build the best trade-off between privacy and performance, which is a very hard problem to solve. But the hope is that from here to there is to build what we call here DIN, so like decentralized intents, in that division that we have seen so far. Anyways, yeah, thank you. That's my talk. Happy to answer any question.
If anyone has a question, they can raise their hand. I can come see you with a mic. Any questions for Munir? No? Okay. Thank you very much, Munir.
Anyways. Thank you, guys.
Yeah. All right, our next speaker, it's a little bit early for our next speaker, so at 11 o'clock, we're going to have Alex Glukowski here from ZK Sync.
I can stay here. Is this working?
Yeah.
One. Okay.
All right. So our next speaker, Alex Guchowski, co-inventor of ZK Sync. Alex is here to lay out why ZK Tech is not only the most powerful and only way to infinitely scale the Internet of Value. He's here to explain why ZK is the end game, verifiably guaranteeing security and resilience. Help me in welcoming Alex.
I'll actually take this one. Hello, everyone.
Thank you.
Yes, I'm coming from Matter Labs, which is a company behind the creators of the ZK Sync protocol. Obviously, we're building things on ZK for a very long time. We built the very first ZK rollup on Ethereum. And I want to give you an intuition why ZK is the end game, like why it's such a transformational technology. I'll start by saying that, just reminding you that Ethereum is a very young age. It's going to get 9 years old this year. And Ethereum is the representation of the Web3, this new generation of the internet. And if you remember, or maybe kind of like imagine how the Web 1 looked like when it was 9 years old, it was quite unsafe, it was very inconvenient, and it was very slow. And this probably sounds familiar to how things are currently in our world in crypto. And all of that gradually improved. We got faster modems, we got better browsers, better JavaScript frameworks, people started building more usable applications. But there was one thing that kind of enabled the internet as we know it today. It was very important. It was like a small change, a small like specific protocol that kind of like made a tectonic shift, like a paradigm change from what was possible, what was not possible in the web. And to explain it, we have to remember that the internet cannot run on a single server. It's a connection of many networks run by different parties. You know, you can be in Dubai connecting to the server in New York, routed through Europe. You don't know who operates all those servers, right? If you want to connect to your bank or to some medical database or your work database with some sensitive data, you need the integrity of communication. You need to make sure that no one in between can mess with your connection, read your data, but more importantly, write data on your behalf and like transfer all of your money somewhere or like use your credit card, which you're going to put on your web shop. And to achieve that, you needed a cryptographic protocol, and it came with HTTPS. It was not there on day one. The early web, like in early 2000s, many websites were not HTTPS protected. And it was dangerous for this reason, right? And HTTPS, TLS, SSL revolutionized the web. And while the Web 3 today is also quite unsafe, inconvenient, and slow, and all of that is improving, we need something similar. Because the web cannot run on a single, just like the internet cannot run on a single server, the internet of value, for fundamental reasons, cannot run on a single monolithic blockchain. I hope that we all agree on this. Like, it's just technologically not feasible, but also socially not feasible to have like one single all-sides-fits-all solution for all communities, all businesses to just agree on, okay, we're going to be building on this one single configuration blockchain. So there must be multiple blockchains, like a multi-chain world, but it must be seamlessly connected just like the internet is connected, without having to worry, without having any additional trust assumptions about all these people in between. Like, this is not how the world of multi-chain works today. If you want to connect from like Ethereum to Solana and send some messages or send some value, you rely on trusted bridges, also known as multi-sigs. So you just rely on some people relaying the trust for you. And maybe you kind of like, you take two blockchains and you trust the people who run the bridge in between. You cannot really extend this trust like to the next hop, like to multiple like bridges connecting multiple chains. And the future is where we have like hundreds or thousands of permissionless chains that needs to be operated all in parallel and all be connected. And so we need something that will enable this world where the users don't have to think about where they are, don't have to think about bridging in the first place. All they do is like they have their account with wallet on, like they have some assets on chain A, because you cannot, you know, like you think of chains as cities. You can only physically be present like at one point of a time in one city, or your car can be in one city. You can move it over bridges or roads to other places, but like at any given point of time, it's in one place. Same with value. Your value can be only on one chain, right? So once you have it, like let's say like on like rollup A on Ethereum, what you want to do is you want to interact with a dApp on some other chain. You should be able to do it in just one click, right? Like confirm in your wallet, and it goes, transaction goes there, does something atomically, and comes back with a result. And to get there, we need trust-free interop at arbitrary scale. Just like the internet, you don't think like, oh, internet can only run on 1,000 servers. No, you can add more servers, more data links. You can expand it indefinitely without losing this seamless connectivity, because HTTPS solves it for you, right? Like no matter how many hops or connections are, like servers are between, you always operate end-to-end encrypted and end-to-end authenticated. And we need the same thing here. And the naive approach is, as I said, like just don't scale trust. They can scale something, but not really trust. And we need a transformative invention. And here the zero-knowledge proofs come to the scene. Because zero-knowledge proofs, how many of you are familiar with zero-knowledge proofs? Okay, great. So you probably know about the privacy aspect of it, and you know about the succinct proofs of computational integrity. Computational integrity is a much more important property of the proofs. We basically compress computation. We can perform a very large array of operations, produce a proof, and then anyone can verify it in less than 1 second from a mobile phone. And this way you you do a very small computation, but you verify a very large result. And this enables, like if EVM is HTTP of the blockchains, then ZK is the HTTPS of the blockchains. Because like in the world of blockchains, you need to scale trust in computation. Like what blockchains do, those are like decentralized databases. Decentralized authenticated databases that operate on like a large state computationally, and then anyone can verify them. It's verifiable computation, right? So with ZK, you extend this trust like indefinitely to as many chains as you need. And if you want, like I also want to give you an intuition how this works, just like internally, why it's possible. Through recursion. How many of you are familiar with recursion? Great. So let's start with a simple transaction on a ZK rollup. We can produce a proof. Like the transaction can be large, it can be doing some like complex things, but then we can produce a short proof of verifying the operations, all of the logic of this transaction, including signature, like sender balance, recipient balance correctly updated, all the logic of smart contracts executed, etc. We have this one single proof. Then we can take proofs of all of these transactions and generate a proof that verifies multiple proofs together, which is quite a simple thing, because verifying the proof is also computation. And then you can repeat this process. Then you can take the proofs of proofs and generate a proof of them. And you can repeat it more until you get the single proof of a block. And then you can repeat it further until for multiple blocks, until you combine it into a single succinct proof that verifies all of the blocks of all the rollups that settle on Ethereum. What you can do next is you can verify the Ethereum execution itself, Ethereum's block. And you produce a single proof which you can verify from a mobile phone. And voila, we turn all of the mobile smartphones in the world in Ethereum full nodes. Like you have 1 billion, not light clients, actual full nodes that verify every single transaction on Ethereum from Genesis and on all of the rollups, ZK rollups, that settle on Ethereum. And they can all trust each other because they don't trust people. They trust math and code. Yes, if you have a error in the protocol or in the code, of course, it's going to be a problem. So you want to go follow security practices. But as long as the code and the protocol is safe, it's bulletproof. It's just math. It doesn't matter what incentives people have, who is compromised, who is not compromised, how the keys are managed. All of that does not matter. You trust pure math, which is very, very powerful. And this is what I would call ZK singularity. A single ZK proof that verifies everything from your phone in 1 second. And this is happening this year, and it's time to build on ZK. Thank you. Do we have time for questions?
Do we have any questions? Do we have any questions? If you can just raise your hand.
Yeah, thanks for the presentation. I'm just curious. So I think one of the challenges that ZK rollups are facing today, or you can tell me if it's a challenge at all or not, is the gap between producing the rollup block and actually producing a proof, which is why many of rollups, they actually bundling many blocks into a single proofs, but from user's perspective, as your example with mobile phone, it actually might look like, well, first they send transaction, but then they need to wait for some time between this, or when this transaction will actually be verified, when there is a proof actually put on Ethereum. We also need to take into account that Ethereum finality is slow, and also maybe to reduce this gap, we need to add more hardware to compute this faster, but then it actually gets very expensive to generate these proofs. I don't know how ZK Sync team is solving these challenges, basically reducing the gap and reducing the cost of producing a proof. Yeah, thank you.
Those are great questions. So let's start with latency. The latency is today some minutes to generate the proof. It's going down to seconds. We have the new generation of the protocols and better hardware. The proofs, from the moment you submit your transaction to the moment you have a proof of some checkpoint of some block to this transaction, by the end of this year, it's going to be 15 seconds. Right? So and then from there, there are teams working on a hardware acceleration, what they call VPUs, verifiable processing units, specifically for cryptography, also general purpose, like GPUs for graphic, you have VPUs for cryptography. It will bring it down to basically close, let's say 2 years from now, it's going to be real time. ZK is going real time, synchronously with generating transactions, you will be generating almost with a lag of 1-2 seconds, you will be generating proofs. Now, but even if you have to wait 1 minute, this is nothing than comparing to optimistic rollups where you have to wait 7 days for objective verifiable finality on layer 1. So that's with regard to latency. With regard to you have to wait for Ethereum finality, today the finality of Ethereum blocks is roughly 10 minutes. This is going to change and we're getting to single slot finality, so it's going to be something like 12 seconds. But how is it different from any other transaction on Ethereum? If you send any transfer, any interaction with smart contracts on Ethereum, you are subject to the same finality limitations. So it has nothing to do with ZK. ZK does not affect it in any way. Optimistic ZK rollups all have the same problem because we all depend on Ethereum. So with single slot finality with 12 seconds, it's probably going to be sufficient because what's going to happen is the L2s, ZK Sync, for example, is working actively on decentralizing the sequencer. We already have a test net with a decentralized sequencer running on hot stuff consensus with less than 1 second blocks. So from a user perspective, when you submit a transaction, you will get close to instant confirmation, in less than 1 second, that transaction is going to be included in the next block, and it's going to be signed by the majority of the stake, or the quorum of the stake of this decentralized sequencer. So they cannot really revert it without being slashed. It doesn't matter what happens on Ethereum, they already promised to you that it's going to be included. So most likely, if your transaction is on a small scale, up to $1 million, it's probably sufficient for you to know that the slashing is going to be much higher if they revert this. And remember, they can never do anything invalid. They cannot mess with the state. They can only like revert, like reorg the blockchain, right? Worst case is a reorg, just like on Ethereum. So your anti-reorg guarantee is backed by the stake. But if it's like really large, if you want to send like $1 billion, then you probably want to wait 12 seconds for Ethereum to confirm, right? So like it's your subjective decision on how long you want to wait for finality. Now coming to the hardware and the costs of hardware. It does not matter how much hardware you need to add, because you only add hardware. You throw hardware at the computation if there is something to compute. So you only need a lot of, like, if you have like 100 or 1,000 times more transactions, sure, you need 1,000 times more hardware, but that's logical. Just like if you scale any cloud computation, if you have like 1,000 times more users, you need 1,000 times more processing power, but those users will be paying for it. For like all what matters is the cost per transaction, not the total cost, right? Like, and the cost per transaction is small. Like, look at L2 fees is a bad source. It's not very reliable, but if you go to Grow the Pie or to guessfees.io, they have a really nice visual comparison of the costs of rollups. ZK Sync is like one of the cheapest rollups. Like we're like slightly more expensive than Arbitrum, slightly less expensive than Optimism and Base, with like 1 or 2 cents per transaction on average. Right? And so this is already this takes the on-chain component into the account plus the computation. You have to pay for computation there. The computation is very cheap, and it's getting like by the end of this year it's going down 10x, and with VPUs it's going down another 10x. And it's going to be, I mean, it's never going to be negligible, because your marginal cost is always important. Like going from 0.1 to 0.01 to 0.001 makes a huge difference for financial applications, for DeFi, for high frequency trading, because they can do like more trading and like lower margins. And bots can always exploit any additional reduction in the order of magnitude of the costs, but it's going to be like negligible compared to the cost of data availability on rollups. So like definitely better than optimistic rollups, because we can do better compression. ZK Sync and Starknet are the only two rollups that do this. We use the state delta approach to publishing the state diffs. So basically we don't publish every single transaction on Ethereum through Ethereum Data Availability Network. We publish the outputs of the transaction. Only like what changed after each block, which storage slots changed. And so it enables us to make the footprint, like the cost of data availability is like 50% cheaper than optimistic rollups. And you could see it in the cost benchmarks before EAP 4844, like very visibly. We were cheaper by 50% than any optimistic rollup. Cheaper than Arbitrum, cheaper than Optimism, like all of them. Now with EAP 4844, because of this like 1 cent, like less than 1 cent, computation costs, it's hard to see, but it's in there. And when the gas prices on Ethereum will go up, optimistic rollups will be more expensive again. And this is going to happen. More questions?
Anyone else? Yep.
Thank you for your talk. So you sort of pull the analogy of ZK as an equivalent of HTTPS, but HTTPS is like a bidirectional thing in which two entities would create a connection, and from their perspective, what they are doing is sort of symmetric. But for the ZK singularity thing that you later described, it's not symmetric, as in there is asymmetric nature of data source or data availability, so that the prover has all of the data and the verifier verifies the last step. But the verifier may not be able to generate all the data and do all of the intermediate steps should they require it. So my question is, isn't there going to be multiple layers of trust on data sources as well? And what is your comment on the bidirectionality vis-a-vis your analogy to HTTPS?
This is a great question. So this is a rough analogy because obviously those are very different protocols. They operate in a different way. You could also argue that HTTPS can be asymmetric. If I just browse a website with HTTPS, I download the data from this website, but I don't upload anything, right? And it can actually be like in the protocol itself. Like you start with asymmetric key, where you here's a better analogy. Like the website has a certificate of authenticity, which I can verify through the root of the certificate chain, but the user does not have and does not need one, because the website does not need to authenticate this user unless the user becomes a user, like gets an account and so on, right? So also in HTTPS it can be asymmetric, and and it's a good thing. You can communicate, like let's say like you have two different users or two different blockchains. The message can be like one directional, unidirectional from chain A to chain B. You can reciprocate and send a message from chain B to chain A, but you should not need to know all of the data of chain B if you operate the chain A and vice versa. And a good example of the use case where you actually want this asymmetry is banking chains or enterprise chains. So we are in conversations with a lot of financial institutions, banks, like trading companies, like big financial providers. What they want is they want interoperability, but they don't want to disclose privacy of their own users. So they actually want this property. They want to be able to prove that something that affects you happened correctly, but not disclose anything that happens to the other people. And honestly, you also don't want to know, not because, like, you know, irrespective of privacy aspects, you should not need to maintain the state of everyone else. Like, imagine that like the monolithic thesis is right, and like everything can be done on a single chain. Let's say, I don't know, like Solana or something, like, you know. That means that you as a full node operator need to maintain the state of all the applications that run on this chain. All of the games, all of the meme coins, all of the like, you know, like whatever applications that people are building there. And the more people build, like we have 10 billion people in the world, we have millions of institutions, millions of developers building stuff. All of a sudden you have to maintain all of that, you have to verify all of that, like put throughput of data for all of this transaction. Why do you care about them? You should not. You should only care, like, is my data correct? Like, is my account, like, can I verify that whatever new next block was produced did not affect my account in any negative way, right? And that's what zero knowledge proofs enabled. Like, you only care about the state that you care about and ignore everything else. And this is a beautiful thing. I mean, this is not like, this is a fundamental enabler of this internet of value. Otherwise, it's just invisible. Like, everyone cannot verify everyone else's data and state and computation. Daniel.
My question is, so if the operator of the rollup becomes uncooperative, then can the users themselves exit the rollup to layer 1? And if so, what happens to smart contracts that are on L2?
It depends on whether the ZK chain is a rollup or a validium. The difference is how you handle the state of this chain. In both cases, you use your knowledge proofs to verify validity and like block transition and guarantee that the validity is basically secured by Ethereum 100%. Like, nothing can be wrong there, right? In the case of a rollup, the state is published to Ethereum always. So any observer from Ethereum can reconstruct the state. You can run a very simple program which collects, like, picks all the outputs and applies them together, and then you get the new block, like the state after the new block, which is an easy, very lightweight operation, unlike optimistic rollups. It's very easy to do. So if the operator becomes uncooperative, And in our case, in ZK Sync, as when we have decentralized sequencer, it means like, let's say the majority of the stake is compromised, right? And they just stop producing blocks. Fine. Then the rollup, then the users can start putting their requests for transactions on what we call the priority queue. So you can just like enforce your transaction from layer 1. And the operators have, the validators of this chain, have to take the transactions from the priority queue and execute them. And if they don't do this, then the chain will enter an emergency mode where anyone can produce blocks on layer 1. And again, they have to take transactions from the priority queue and execute them. Now, it's always possible on a rollup. You pay to Ethereum, the transactions are more expensive. Every single transaction is more expensive, but they give you this property. It's basically the same security as Ethereum itself. No other protocol can fulfill this, but ZK rollups. Only ZK rollups can like have mathematically guaranteed 100% the same security properties as Ethereum. Optimistic rollups cannot do this because you still depend on your ability to submit the fraud proof, and it still can fail, and you know, like whatever. But like, ZK rollups have the 100% this ability. Now let's consider validiums. In a validium, let's imagine you have a banking chain. You have an account in a bank. The bank operates the data, they store it on their servers, they don't publish it to Ethereum. They still use Ethereum to verify zero-knowledge proofs, and they generate zero-knowledge proofs for each block. So they cannot do anything invalid there, but they can like just withhold data for all of the users, and like, or for you personally, right? So what you can do, you can still use the priority queue to submit your transaction, and everyone else can. And if the bank, or like whoever the operator of this validium, will not observe the priority queue, will not push the transactions from there, then the chain will hold for everyone. And that's your ultimate like failure mode. You cannot recover from that, but you can also guarantee that the censorship is not targeted. You cannot target one specific individual user. You can like either serve everyone or shut it down for everyone. And in which case, like all of the state, all of the money in the validium will be frozen, but so will be the stake of the operator. So it's kind of like a self-hostage situation. It's like you can blow up the car, but you blow up with the car, right? And rational actors won't do this because they will lose money. Irrational actors, like motivated by some other external political motives, could do this. Maybe they're forced by some legislation. So this is a risk factor. If you want to operate on a validium, you have to take into account that this can happen. But this is much better than a sidechain where the operators can just steal money. So they have a lot more incentive. They don't have skin in the game. Here they have skin in the game. But yes, this is slightly less secure, or significantly less secure than a rollup. And hopefully we scale Ethereum completely with ZK rollups. Not like validiums for some specific. Sometimes you have things that don't require valuable state, like maybe oracles. You only want to push them and do computation. So like for that, validium works perfectly, or evolution. I think we have one more question.
Yeah, we can take one more.
Yeah, thank you. Great speech. Let's imagine, you know, we have a future, as you mentioned, that every bank has a separate network. Let's imagine one bank has a ZK rollup network, another optimistic rollup, and it's linked, you know, through CCIP, for example, protocol. So how, and I would like to, for example, tokenize my deposit, I transfer it from one bank network to another network. So how do you foresee really, you know, how, first of all, ZK rollups can impact this future, and how you foresee overall, because that's more, let's say, futuristic view, because, you know, if on one side will be the optimistic rollup, on other side the ZK Sync, or it could be, for example, ARF Recorder for one bank, or Avalanche subnet for other bank networks. So how it will work, let's say, together. So what is really the future in your view?
Very simple answer. Like, a great question. I don't see the future where optimistic rollups exist. You're like, in all honesty, like everything is going to be, all of them will have to upgrade to ZK or become irrelevant. Because the way, like, imagine like rollups as islands. You have like different activity there. So to connect ZK rollups, you can build bridges, like actual highways. You know, like think like the Palm in Dubai is connected with a bridge. You just take a car and you drive there, right? Now, optimistic rollups can only be connected with ferries, and those will be steamer ferries. Like it's an island where you can only reach like by 7 days sailing to this island. So like to connect it to like, so sure, you will have the ZK rollup ecosystem with like this highway bridges connected, and you will see these far islands of optimistic rollups with like daily sailing steamers going there and back like in 7 days interval, right? Will this coexist? Maybe. I mean, like we'll have like the bustling economy of the ZK rollups and these like far islands.
All right. If you'd like to contact Alex, it's Gluke64 on Twitter.
Yes, or ZK Sync on Twitter.
Or ZK Sync. Yeah, so let's
Thank you.
Give him a welcome. Yeah. All right, so next up we have Alex Viñas, Product Marketing Manager at CowSwap. So Alex is here to explain the new era of programmable intents that CowSwap is enabling with this technology, cow hooks, cow AMM. So cow protocol is no longer just a swap intents machine engine, but a generalized intent matching executor for all types of orders, logic, and transactions. Give a warm welcome for Alex.
Or can I just go? I'll go with this. Good morning, everyone. Thank you for being here and making it all the way through the week. So I'm Alex Viñas. I work at CowDAO. And today I'm going to give a talk about the rise of programmable intents, which I guess is a topic that has been like picking up lately. And I've broken down the talk into 4 topics. First, like a bit of history of CowDAO. Then what are the current problems with intents, but more specifically with smart contract intents. Then I'm going to introduce you to the concept of ERC 1271 smart orders. And then finish with what we think is the era of programmable intents. So first, a little bit of brief history. CowDAO is a DAO that was spun out of Gnosis DAO in 2022, and it's on a mission to create the most innovative and protective user products on Ethereum, and soon, most likely, more layers as well. And there are 3 main products that belong to CowDAO. The first one is Cow Protocol, which is the leading intent-based trading protocol. It's similar to an AMM and a DEX aggregator, but with a fundamental and yet much better difference, because instead of just acting like a router, we add a thin batching layer on top of the AMMs and aggregators that allows us to combine multiple intents together and execute them in a single transaction. Not only from that, we're able to gain batching efficiencies, but we're also able to offer better optimizations in prices, because we actually, and that's where the name comes from, we're able to match users via coincidence of wants, which are peer-to-peer trades, and this ultimately leads to much better pricing and the best MEV protection, because there's no actual way to play with your transaction. Then the second product that was recently launching is CowAMM, which is the first MEV capturing AMM. And CowAMM allows liquidity providers to protect themselves from arbitrageurs that take advantage of them by connecting their trades with centralized exchange and then tapping onto their liquidity at a much staler price. This is called LBR, and CowAMM protects liquidity providers from LBR by leveraging smart intents, in this case ERC 1271, to trigger the transactions to actually protect the liquidity providers. And lastly, MEV Blocker, which is the leading MEV protection RPC on Ethereum. And this product was mainly created for those, let's say, lost souls that don't trade on CowSwap and trade still elsewhere, that then if they don't want to have the best protection, then at least they have some additional protection guarantees that come from CowDAO as well. But today I'm only going to focus on Cow Protocol and CowAMM because the talk is about intents and not just about MEV. But how was Cow Protocol designed to work? Well, Cow Protocol was designed to work from the beginning for all different types of users. The first one was for retail, right? Because the whole idea with the type of account abstraction that Cow Protocol has is that nowadays it's very complicated to make a transaction on Ethereum. You have to know what the right gas price is. You have to be very informed into where is the best AMM pool to trade and many different aspects to take into consideration. So Cow Protocol was designed with this in mind, in a way so that users, instead of actually creating the transaction for themselves, they just create an intent to trade, and a professional party called the solvers are the ones in charge of adding all these complex technical stuff that blockchains have. The second one is for smart contract wallets or smart contracts in general, because until Cow Protocol, the standard was that with a smart contract, the moment you created the trade, you actually had to compromise the exact amount of tokens that you wanted to get out, which opened your trade to MEV, because people already knew from the transaction the amount that, the lowest amount that you were willing to take. And not only that, but because you are a smart contract wallet and you usually have more or less at least like 3 signers or 2 out of 3, you had to spend time to connect with the other signers to execute the transaction. So this time that elapsed between the actual transaction creation and the final submission or execution of the trade also led to like suboptimal prices. And lastly, because of DAOs, because DAOs have been kind of like the promise of Ethereum, but they haven't truly like unleash their powers, because if you add, because if a DAO is a smart contract, not only do you have the same problems as the smart contract wallets, but you also have the addition of governance, which 10x the problems, because then you have to at least, wait 5 days until the proposal is gone. So it's just a horrible experience, because if you already craft the swap 7 days in advance, then you cannot leave the door open for the market to completely exploit you, because it's kind of very well anticipated, like what you want to get. And the talk focuses on these two, because these two are the ones that so far have suffered the most, because with EOAs, it has actually been somewhat easy to create intents. So what is the problem, right? The problem with the smart contracts is that there is no way to actually create the signature in the same way with EOAs. But there are 2 main problems. There are execution issues and technical issues. But from the execution side, as I said, right, you have the MEV problem. You have to compromise your minimum amount already beforehand. You also have to gather all the signers of the transaction, which delays to the process. And lastly, you also don't have the on-chain guarantees, because there's no one to, like, especially if you can't play this off-chain system, there's no easy way to add the guarantees within your transaction that is going to trigger how you want to do it. And then if you're a DAO, then if you have the governance process, then all these problems kind of like escalate even more. But then you also have the technical issue, right? Because EOAs can create EIP 7112 and ETH type of signatures. You can actually create like an approval transaction via an intent that authorizes this third party to kind of do this computation of chain and submit your transaction on your behalf. But if you're a smart contract, because the smart contracts don't have signatures, you don't have private keys, you're not able to create the actual signature, right? So then the smart contracts or any DAO is actually forced to trade on the on-chain route. And at Causa we used to do this via the pre-signature route, which basically is just creating a transaction that like submits all the parameters of your orders on-chain, who then like an off-chain system like picks up. But this is not problematic, but it's a worse UX, because then you actually have to pay for the transaction to place the order, and you cannot leverage the advantage of intents like an EOA. So how is this get fixed? Well, with ERC 1271, we enabled the smart orders, and this is actually like rising a lot, because it opens up a lot of possibilities, right? And ERC 1271 is basically like a smart contract order interactive signature verification. So instead of using e-recover, which is what is used by regular orders, you used a function called isValid signature. And basically what this function does is that it allows your smart contract to actually authorize someone else to place the order on your behalf. Not only that, but because you're the smart contract, you can actually like add guarantees on top of your order, like where is the block time that you don't want the swap to execute until, I don't know, check the Oracle price, or don't execute this swap until the current balance is whatever. And this is very interesting because then it truly enables smart contracts to actually place intent systems. Because the way it works is then you have this off-chain sort of bot called a watchtower, or called, I don't know, whatever you want to call it, that basically like acts as your butler, let's say, from the smart contract. And what this butler does, or watchtower, is just placing the order inside the Cow protocol order book. And then it's passed on to the solvers, and then whatever the solver wins submits the actual transaction. And then at the moment that the transaction is actually validated, your smart contract is being called to this signature, to the isValid signature, kind of like, hey, someone else posted this transaction on your behalf according to your parameters. Are you okay with it? Yes or no? And then if the watchtower has behaved correctly, because then it's kind of like read all the parameters that the smart contract wanted, it should be correct, and the smart contract would say yes, and then we have the swap, or we have the intent already placed. So the first use of smart orders that CowSwap or Cow Protocol implemented was actually like the ETH flow, right? In CowSwap at the beginning, you couldn't sell ETH directly. Why? Because ETH is the native token of the chain, and it's not an ERC20. So you actually have to wrap it into WETH. And even though that's, I don't know, quite a simple thing to do, just wrap your ETH, there were still many people that complained and wanted to trade ETH directly. So we developed this intermediary contract that leverages smart orders to basically allow users this. And basically the flow is that the user sends the ETH directly to this intermediary contract, and then this intermediary contract is the one that's connected to the watchtower, who actually ignites all the transactions. It basically like picks up the information that the user submitted via CowSwap. It initiates the order to wrap the ETH, and then it places the smart order into the Cow protocol order book, and then solver compete, and at the moment of like submission on chain, then the swap happens, and the user gets in this case, the DAI that they wanted. The second use case was developed by Yearn in collaboration with the Cow Grants program, and it was actually a specific use case for unleashing like the governance DAO powers. And this was the product that ENS leveraged. Well, ENS, Aave, and Nexus Mutual have already leveraged this product. And basically, is the idea that you can precondition the swap for your governance kind of vote or your governance process. And the whole idea is, again, what I said before, right? If I want to make, like currently, either you appoint a treasury management if you're a DAO, and then kind of like the treasury managers have full control of the swaps that they want to execute in the treasury, but there's no really like more opinion within the DAO, because you kind of give full power within the certain amount of assets of the treasury to that treasury team. But now with Milkman, what you can do is say like, okay, we're going to create this proposal, and because this proposal, unlike others, uses ERC-1271 and doesn't compromise on the exact amount of the tokens that we want, then we can still go through governance and get like the most optimal price. Why? Because the way that basically this works is that you say, okay, you specify an Oracle price, and you specify the time preference that you want the trade executed. So basically what you're saying is like, hey, I want to sell 10,000 ETH and using this Oracle price. And this is going to tell me that like at the moment that the governance, if in case the proposal passes and the swap has to be executed, then this bot is going to submit this transaction to the Cow protocol order book, and the guarantees that the DAO has is that at the moment of settlement, right, it's going to ask this isValid signature, hey, this bot proposed this order to sell 10,000 ETH, and if not mistaken, this is within the current price that you wanted, which can be like, I don't know, 1% of whatever Uniswap pool you decide, or 1% of, like, not to be farther than 1% than Chainlink Oracle or whatever Oracle you want to pick. And then this way is allowing smart contracts to actually like put the swaps back into the governance process without having to worry about like signatures, compatibility, or MEV, and still getting the best possible price. But the problem is that these examples are single smart orders, and they have drawbacks. The first drawback is that they're like quite costly in terms of gas, because you have to do so many computations and do the on-chain guarantees. They're a little bit costly. Like they're not the most optimized like gas settlement. The second one is that they require the money to go to this intermediary contract who can then talk with the watchtower. And of course, this is not like a major drawback, but I don't know, if you're a DAO and you're not very risky, you might not want to have to deal with sending the funds to this intermediary contract. And lastly is that they're single order based, right? If you want to automate any process as a DAO or you want to do recurring swap, it's going to be very annoying to have to sign the transaction or craft the transaction every single time. So this is where the programmable intents come to play, right? In Cow Protocol, we created a programmatic order framework, which is a conditional smart order framework that allows you to indicate many intents to trade with a single transaction created in the beginning, right? And the beautiful thing is that you can create without any trust assumptions, and you can actually add these on-chain guarantees. For the moment, it's very focused on the Safe wallet. So this is interesting because right now also soon, next week, the Safe is going to release the token. So there's a lot of things to see how the market behaves. And there are a lot of new things that you can do. And actually, the programmatic order framework allows the Safe to become a first-class citizen for trading because you can actually turn it into, I mean, I don't know, but people would say an AI agent because you can kind of condition all the orders or all the different strategies that you want to trigger. And then with the help of this bot, it will just basically use the funds in your Safe to actually trade on your behalf since it has your intent permission. And we're already using this for TWAP. For example, in TWAP, this is the architecture for TWAP. If you leverage the Safe, you have basically this middle contract, which is the composable cow, which is the programmatic order one. And here is the famous watchtower that we have, right? And in TWAP, which is time-weighted average price, in case anyone is aware, you want to create a set of recurring orders. So say, I don't know, buy ETH during 10 times for the next 6 hours. And the current process that you could do that is that you would have to sign the 10 orders. But with the smart programmatic order framework intents, you can do is simply create this major intent to trade that then is going to give the permission to this watchtower to actually create all the orders on your behalf. And basically, the flow would be the same, right? You create the order, then the complete order structure, the conditional order is deposited in here, which can be any decentralized storage network, IPFS, whatever you want. Or you can also skip that if you run your own watchtower. And then the watchtower is the one in charge of creating the discrete orders at the time that your smart contract has specified. And then from here, the watchtower just posts the order via an API directly on the order book. And then from here downwards is as normal as any regular order on CowSwap. This is also very similar because in CowAMM, it also leverages the proof of the programmatic order framework, because in this case, basically, you deposit your tokens that you want to LP on your Safe, and you do it at 50-50. And from there, you specify the watchtower, which price checker or oracle you're going to compare or you're going to reference your pool from. And basically, what the watchtower is going to be doing at all time is comparing if the if the position in your Safe is completely balanced 50-50 based on the reference price that you set. And in the case that it's not balanced, then it's going to propose a trade on the CowSwap order book so that the assets are rebalanced again. And the beautiful thing is that once you've done that, you don't have to worry about this because you can have the watchtower basically rebalance your position at all times. But another way in which actually the intents come to play is that now also if you don't want to have the watchtower, or if you're a solver and you're more advanced than the rest and you want to actually take advantage of these several CowAMM pools, what you can do is once you place the order, once you're aware that this liquidity pool exists, you can just treat them like any other AMM and liquidity pools and basically leverage the CowAMM as a liquidity pool with much better rates. Because the only way that this liquidity can be accessed is either through the solvers or through the CowSwap badge. And therefore, if you as a solver are indexing this liquidity, you can offer better rates for those orders that are coming through CowSwap. Post on your behalf is accurate based on the conditions or the guarantees that you established. So what are the use cases for the programmatic order framework? The first one is kind of like a major one, like a fee crop recollection. if you are a DAO that has to like collect fees from swaps or from any other different activity, you can actually use this framework to automate like a weekly or monthly swap to simply like, you know, once the balance of this contract hits a certain threshold, execute the swap into whatever token I want, and then send it elsewhere so that we're always secure. Then, like, you know, there's not more funds in the wallet that we want to, in the smart contract that we want to not put in danger. The second one, for example, is payroll. If you're a DAO and you want to automate the payroll of your DAO contributors, you can actually like create a swap order that says, okay, for the next 12 months, at the end of each month, basically create a swap that grabs my native token, sell it to a stablecoin, and automatically distribute it to the contributors. And the beautiful thing is that also because the programmatic order framework uses Merkle tree for storing the conditional orders, you can actually like create unlimited discrete orders. Not only that, but it's very easy to update because then you can just replace the new order with just a new Merkle tree. And then, for example, in the case of contributors, if when you created the swap, you had 12 contributors, but by the 6th month, you only have 7, instead of having to ditch the entire order and create a new one, you can just update the new Merkle tree and the watchtower will pick it up and it will know that now we're only like 5 contributors. The other one is the case of, for example, CowMM, but this can be taken like much farther apart. It's basically portfolio rebalancing, right? Like you have a strategy within your safe wallet and you want to say, I don't know, in the case like keep the portfolio 50-50 at all times based on this price reference, or if you want to do like multiple assets, you can also do it. I mean, this is different than CowMM, but you could do it. Basically say like, I want to assign weights to this portfolio, and as long as one weight becomes more valuable, like one type of asset becomes more valuable than the other, just basically like rebalance so that the weights are constant at all times. Then also, you can do like collateral position manager, right? If I have a CDP open right now and I'm here and I don't have some sort of script or bot that is in place, maybe I'm going to get wrecked because I don't have my private keys and I'm here in Dubai and I don't want to like even have to think about it. But with the programmatic order framework, you can have the guarantee that, you know, as soon as certain thresholds are hit, the bot, in this case the watchtower, will just trigger the transaction on your behalf and you can just enjoy calmly wherever you are. Then TWAP, which is the case that I already explained. And then also you can do like conditional orders such as a stop loss, right? Hey, again, if you want to protect yourselves from volatility, but you don't want to have to carry the computer at all times, you can basically just program the order to trigger based on certain outside conditions, and the watchtower will do actually the job for you. So where's the conclusion of all this? Well, the conclusion is that intents are entering like mass adoption, because the programmatic order framework expands the way in which intents can operate within smart contracts, which ultimately is kind of the dream, because we've always within Ethereum talked about like the programmability of an auto execution of all these kind of financial transactions. But with EOAs, we have somewhat achieved that, but not with the smart contracts. And the beautiful thing is that then with the smart contracts, you can also place simultaneous conditional intents all in one go. And that, in combination with cow hooks, basically is it gives you the ability to express an intent in combination with your swap, right? And the good thing is that then also it allows to make it like such interaction with intents recurrent. Because basically with cow hooks, you can add like pre and post interactions to your swap intent. And this would allow you to, for example, say like, okay, bridge stake a token or re-stake a token, swap, then stake it again, or claim a token, swap it into the coin that I want to put again into the LP, and then re-put the position. Or mint, swap, approve, like you can add basically any sort of interaction that you want in before and after your swap. So this allows to kind of push the intent language or intent kind of market beyond just swaps. And yeah, the sky's the limit. If you're interested in integrating intents, please reach out at bd@cow.fi. And if you're interested in building, Cow Grants is there for you, ready to give grants. So thank you very much.
Well, thank you. We have a couple minutes for questions. If anyone has a question, raise your hand.
it was so clear that no one has
It was
questions.
Very clear. Thank you so much. No question? Okay. So we've heard quite a lot about intent today. Oh, question?
It seems there is a lot of work to do. So is there any expected timeline to reach usability for the intents in CowSwap?
I mean, this is already live. Like, you can already use this today. The problem, I mean, okay, well, yeah, it's already live from the engineering point of view. What is missing right now, and we're working on it, is the UI. So basically, we're expecting that by end of this quarter, if not Q3, that you'll be able to actually very easily within the UI kind of combine these intents within your swaps as well. But technically, it has been already live for a long time. You just needed to know a little bit to code, which not that many people, so it's so tricky.
I was wondering a bit about the sustainability. Do you guys see people trying to attack this model you've got? Have you seen people trying to take advantage, trying to break your model?
So far, no. I mean, in general, the most type of attacks that we get is more spamming to clog the system, just sending many orders. But in general, that's basically it. Because at least with the Watchtower, you can actually make it very private, because currently there are very few Watchtowers running, and the core team has one running, but this is completely free for anyone to run. So if you're paranoid and don't want to rely on centralization, you can actually run your Watchtower and make your orders completely private to you. And then therefore there's no way, because it's within your local storage or your local system or setup that you have, that the information of the orders are there. So there's no easy way to break it.
Right, but for example, you could be DDoSed.
Yeah, exactly. But you can DDoS, but you DDoS the Cow protocol. I couldn't DDoS you, because if you're running it within your own system, I don't know where that is. Right?
Well, unless you do find me, but yes, I assume it's going to be hard. Okay, I have another sustainability question. When do you expect to run out of cow jokes?
I don't know. Keep on going for the moment. Keep on moving.
Hi. I just want to make sure I understood what makes it programmatic. As far as I understood, you're making intents that are conditional on smart contract values, as well as intents that are time dependent, like recurring or occur at a certain time.
Yeah, so basically the idea is that instead of treating the orders like single, only taking care of one case, you can basically create a conditional tree of order that then has n discrete orders, that these discrete orders behave according to guarantees that you want to do. So for example, I don't know, unless balance is above this certain threshold and price is not this, don't trigger. And then this is replicated for each kind of discrete order that you have created within the conditional order.
Yeah, but the way it's programmed, is the condition general? It's any condition, any value in a smart contract?
Yeah. This is you can sort of think of the whole point of the framework is that, we have some implementations, but the whole idea was for any developer to kind of come up with their own conditions and focus on their own condition logic. And then the framework takes care of all the rest in terms of submitting to Cow protocol order book, connecting, and then putting all the parameters or the order digest in the correct way for the protocol to kind of kick it in and pass it on to solvers.
Okay, thank you.
Okay, one last question.
So this is actually a follow-up to the previous question, that if everybody can write their own conditions, how do you deal with the halting problem? How can you keep the complexity of evaluating the conditions in check?
Well, the conditions that are, it's basically, I guess, the harder you make it, the more you have to signal the Watchtower to take into consideration. And then maybe there's I guess We haven't really like tested with 1,000 conditions, no? Because I don't know if you want to make a financial order with 1,000 conditions. But technically, like, this is handled by the watchtower. So if your watchtower can, like, you know, absorb the amount of conditions that you've put, then there's no limitations. But maybe this is more technical and
Thank you. So, well, thank you for your presentation.
Thank you.
Now we're going to move to the panel to further discuss this intent. So please welcome our panelist, Sarang Parikh, advisor at SushiSwap. Sorry, is he there? No, he's not. Okay. Sergey Kunz, co-founder at 1inch. Alex Vitsaya, so at CoSwap. Munir Benchmeld, co-contributor at Paraswap. And Adrian Brink, co-founder at Anoma.
Hello, hello.
Tend to come.
No intent.
Hello.
Hello. Hello. Yeah, I think 1inch. Okay. Yeah, it's there. Maybe. Yeah. Yeah. Then we can make one. We can. Yeah. Okay. Sure.
Oh, this is interesting.
Is it intent?
He intends to come.
Waiting for the solver to submit.
His intent hasn't been routed yet correctly, and solvers can't find it.
Solver hit wrong API.
It's a very general intent. Someone from 1inch, and now we're trying to compute who comes.
Testing, testing.
There you go.
Awesome. So the solver just returned. So yeah, we have a panel on intents. So let's just introduce ourselves. I'm Sarang. I used to lead engineering at SushiSwap, and I'm an advisor to them. And I'm going to tell everybody to give like a 10 words definition of what you think intent is. For me, it is whatever I don't know how to do it. Like I just give it on the intents. You know, just people to do it. That's intent for me.
Hi, my name is Kirill. I'm the lead backend engineer at 1inch, where we are working on on-chain aggregation and also intents, our fusion protocol. For me, intents, it's something hard that can be simple for the user, and professional market makers will do everything for user.
Hi, Munir, founder of Paraswap in Portuguese. I believe intent is a simplification of user objectives that we use in our daily life. Like an example of booking an Uber, we don't get to tell Uber what to do, we just tell Uber where are we going, and we just push a button and it's done for us.
Cool. Yeah, I'm Adrian. I'm co-founder of Anoma. An intent is a partial state transition. You say exactly what you want. You want to go from A to B. You don't care about how it's computed because you've sort of cryptographically committed that you have A and you want B, and then someone else can figure out the actual compute, and you don't care whether there's one counterparty, 1,000 counterparties, 15 different bridges. It doesn't matter. You just define A to B, and the rest is figured out by someone else.
So I'm Alex. I do product marketing at CowSwap, and for me, intents are limit orders. No. They're. I mean, I agree with what everyone has saying. It's basically a way to just express what you want to do, and then especially within this tech, because it's so complicated, it's like I don't care, just figure it out, and then I know I want to get B, and like it's what Munir said. I know I want to get there. Just figure out the route and how to pick me up, and that's it.
Awesome. So since I'm a smart contract dev, one of the questions that I have is, while building smart contract applications, I've not seen a lot of them interacting to intent-based architecture recently, right? There's still some of them coming up. So what are the best ways that, as a smart contract dev, you could recommend me, or tell me some tools, tricks on using your intent apps much more, like a defined manner, and like probably a bit more standardized? I think like you just gave a presentation on that, right?
So I'll give it a short, not to repeat myself, but basically it's developing your smart contract with ERC-1271 signatures, because then you allow the smart contract to kind of create this like is valid signature, and then the order creation is just this function call for the signature and the order digest for, in the case for CowSwap, for Cow Protocol, and that's pretty much an easier way for smart contracts to leverage intents.
Maybe it's important to note here, like the model changes as soon as you have intents. Right now, smart contracts are very imperative, sort of, they actually try to compute things. This is, in my opinion, clearly the wrong model, because sort of shared global compute is pretty expensive, and there's no reason why everyone needs to compute the same 5 values. So like from a developer perspective, the model changes to much more verification. So you sort of define like what are valid state transitions in the system, in my application, and then the application actually just verifies whether a proposed state transition is valid, right? Like if you have a simple trade, A to B, A for B, B for A, in the application you just verify that this balances to 0. You don't actually try to compute the actual thing that's happening. So this is much more moving away from let me define a imperative sort of execution trace towards applications check declarative state updates, and solvers will figure out exactly what state updates should happen, and then they will submit those, and then the application just verifies, which is why also intents are wonderful for ZK, because this is the model in ZK anyway, where we do compute somewhere else and we do verification in the middle.
It seems like also it's a holy grail for account abstraction developers who can have intents integrated natively into their app without having to worry about a lot of details, because now we have a lot of devs who are, I would say in the space for a while, they understand how smart contracts work and all of that, but I think the next million developers that will join the space, they don't need to understand all the details besides what Adrian said, maybe verifying and proving that what happens indeed happens as expected, but they can focus mostly on their business logic and delivering the best possible service to their users.
Actually, because I just had a thought here, which is something I think as a developer, developing applications is just an order of magnitude easier if you're in this declarative framework and more secure, because you don't have to worry about like whether your execution trace is correct. You can just go and just, like verification is just easier to build.
Yeah, but I think that this is a paradigm change as well, right? Because with smart contract, you want atomicity of operations when the user executes it, right? Like either it happens or it doesn't. But in this case, like I was actually trying to integrate like 1-inch limit orders, so I had to create callbacks on my contracts, wait for the operation to happen, wait for your contracts to submit, and then the application flows, kind of moves to the next step. So I think like this, there's this new ideal like paradigm that we need to be worried about, and when we develop apps, which not a lot of people might be catered to, right? So.
Yeah, basically, as everyone said, intents, it's pretty simple architecture where you just need to sign some message and submit to some relayer. But on top of this signature, you can add a lot of business logic, conditions, etc. Like you said, in limit orders. Besides the signature, you can provide some interaction and, for example, make deposits to lending protocols. For example, you can make a leverage trading with it. You can provide liquidity within the single limit order, so you can do any action.
That makes sense. So the other question I have is like, up to what extent we're basically making like the intent architecture centralized? So like back like 8, 9 months, 10 months ago, like where intents were very hot, like everybody wanted to know what that is and integrate it. But now like 10 months later, we find that most of the protocols which actually have intents, or like mainly for order execution, right? There are only very, very less solvers filling it, and that too take up a majority share. I was just reading an article in the morning which said that Tokalabs and Wintermute is 80% of Uniswap X's volume. We have similar numbers for 1inch, CowSwap and other exchanges as well, right? Would that reduce the solver competition and kind of, increase the monopoly of certain solvers into the space? If yes, then how do we solve it?
So if we are talking about the centralization in the high efficient DeFi trading system, you need some kind of balance between the decentralization and centralization. And from our point of view, the main thing that should be decentralized, it's order execution itself, it's the price, and other stuff we can delegate to some peer-to-peer network or just a backend just for storage to distribute the orders to the professional market makers. And so it's makes sense to keep some part of the architecture centralized, but you should always perform an execution on chain.
Yeah, I think from my perspective, so theoretically it's fine that it'd be actually okay if you only have one solver. This is not structurally a problem because solvers can't front run, like users sign over specific state updates. So like as a user, you actually doesn't hurt you if there's only one global solver. Like if one person builds a universal solver that is going to be the fastest and cheapest for everyone, I think that would actually be fine. The important thing is you want to decentralize the architecture so that, or you want to have an architecture where the topology can shift. For example, as soon as one solver starts behaving badly, like as in they try to censor you, there's an easy way for other people to hook into this. So like I think what really matters is, and not enough people in the space ever think about this, is how do you actually build resilient P2P gossip networks that can sort of handle arbitrary intents that then solvers can sit on top. I think this is really by far the most important thing, that we want to have the capability that at any moment I can decide on my own solver. Like either I can say, well, I only want to interact actually with this one guy, or we can all switch away from this one guy because he's starting to censor half of this. Like solving should never be this is, for example, also why I think like having closed source provers in ZK is horrendously bad, because this is effectively, now you've created a lock-in for one solver to always be the only available solver, and then you have centralization problems. So you want to build architectures that are topology agnostic, where topology can flow from actual user behavior, where if people want to switch away to a different solver, they can easily do this. And this even comes not even from the censorship resistant way, but even think of this in terms of latency, right? Latency really matters, and latency is fundamentally determined by speed of light. Like if we want to get this faster execution, we should do local solving in this room, because we can have like fiber optic cables between our machines right now. This will, like, no chain will ever be faster than this unless they break the laws of physics. And so you want to have architectures that support, either we can have a global solver because maybe I care about cost but not latency, but maybe I also, when I really care about latency, I want to have the same architecture should be able to support that I can like easily roam between all these different topologies.
I mean, I think, so for one hand, it shouldn't matter if it's centralized, like at least the like input of creating the intents. What should matter is like that, kind of like the availability to access these intents is decentralized. But at the same time, like going a little bit on what you say, it's a little bit like idealistic to kind of think that there's not going to be centralization, because there are all these other things like latency and like, I don't know, vertical integrations that lead to centralization. Like we haven't solved this yet at the Ethereum level with builders, for example, where like, this system with PBS was supposed to be more open and more decentralized, and yet it has actually made it more centralized. And we have builders which I'm not getting into the point that if they should or they shouldn't. It's up to each person to decide, like, you know, what laws they follow and whatever. But it is happening that it's censoring. And yet, if from the chain level we can't really figure it out, it's kind of, I don't know if naive or very idealistic to think that at a much lower stack, which is even harder to deal with, we're going to be able to solve it, at least in the short term.
I would say that, like in PBS, the problem though is that builders exist, but no one really worried about how to build an opt-in network stack that where you can easily like reconnect. So as a result, like we are locked into these like couple of handful of builders that that are the only people that actually are connected to the relays, and the validators only connect to like 2 relays, effectively maybe 3, right? I actually think long-term latency really plays in our favor, because latency is like the one thing you can't get away from. And so like this, I think, will heavily favor localized solving and very decentralized solving, because this is by far going to be the lowest latency thing.
It's also an open market, right? Because the most efficient players are always going to be winning. We see that in exchanges in general. Like you see centralized or decentralized exchanges, you will always have one party dominating others simply because it's more efficient. And also in Ethereum, we have Lido that's taking a large share, not because the system is decentralized. Like Ethereum design, I agree with the idea that the design should be decentralized, should maximize on the core design architecture, decentralization, but also they will always have actors that will emerge simply because they are more efficient than others.
Yeah. So you mean to say like Lido should get 50%? I'm just joking, I won't get you cancelled, you know. So yeah, that actually drives me towards my next question is, you know, that, okay, like on Ethereum, you had flashbots that lets you access, you know, a lot of MEV stuff in a much easier fashion. Before that, people could still do it, but they have to go talk to, you know, a lot of like sidechain, like these Chinese miners to get those transactions in, and they were used to do it on very case-to-case basis, right? Flashbot made it available for all. We have now, you know, like before 4337, people still used to have gasless transaction, but they had all of that in the private mempool kind of thing, right? This is what the scenario, what I feel is for the intents, right? 1inch has private, Anoma, CowSwap, they all have their own private and like, you know, permission pools where like, if I just want to go write solving for it, I couldn't do it as easily as, you know, I would be able to run a validated node on Ethereum, right, for instance. Or maybe like participate in the 4337 network, right? So does that call for a standard for you guys to kind of collaborate and share your orders? Or is that something you would not want to do because that's coming from your order flow, you know?
So Anoma doesn't care. Anoma is its infrastructure, right? Like it's just intents. We don't know what those intents do. They may be messages, they may be trades, who cares? Yeah. So in that sense, if you want to build an application on top of this, sure, you can make the choice to have private order flow that you do not gossip on, right? Like a front end could make a choice that you only submit, the front end only submits it to one, effectively one solver, and this becomes now private order flow. Yeah. But there's nothing in the architecture restricting this. It's like, I think in the end it will come down to, if we build open architectures, it comes down to user behavior of whether they want to take advantage of these open architectures. I think this is actually one of the big problems with flashbots and like the entire thing in Ethereum. Like at the moment we have this very ad hoc thing where like a bunch of IP addresses are fixed, and it's very difficult for users to actually influence the topology. And so as a result, we're seeing some amount of centralization here. And I really hope that like Anoma's intent machine for Ethereum can start addressing some of this, where it's like, can we make this a more open architecture that where users can more easily pick where they like what the topology should look like.
Yeah. I mean, like in L2s, right? Now you guys have a lot of power because L2s don't have anything like flashbots, right? Like I'm not like maybe let's say in case of Arbitrum, right? We hope that Arbitrum sequences doesn't MEV us out, but you guys can because you guys are getting the native order flow in most cases, right? Like, shouldn't this power be kind of like shared between all of us as a user? Because as a user, I might get bad execution on one of these.
I mean, yes and no. Like, because the problem with the standards is that they're kind of like self-interest and opinionated. Mm-hmm. And unless you go like the Anoma route and kind of, which maybe Ethereum should do or not, like this is the standard for everyone or like for all this network. And then applications decide like how you treat them and like how you want to create your own architectures. Or else it's just going to be opinionated. And then ultimately like the leader of the standard is going to, you know, sweep the standard towards their infrastructure.
Yeah. I mean, they're always going to be opinionated, right? There's standards of standards of standards, right? But you still got to pull off something, you know?
Yeah, there is a small problem with standards. that each protocol try their best to optimize the smart contracts as much as possible in terms of gas usage for the solver. Like, because the user's price also depends on the gas cost of the solver. If the protocol itself consumes a lot of gas, it will not be so profitable for the user. That means that each protocol trying to optimize each of their functionality as much as possible. And if we will have some shared standard how to do this, there is a way that the smart contracts would not be gas optimized as much as we can.
Well, I would add that this field is still in its infancy. We've been talking about intent like when you guys launched 2 years ago. Building standards at this time may not be efficient for innovation because we haven't discovered yet what is the best design. So we still have a lot of opinions, a lot of projects working on decentralization, working on improving the flow, on maximizing the supply side. Like you mentioned, we still have this centralization on the supply side. How do we get more solvers? How do we make the barrier to entry lower? We see now some DEXs building their own solvers so that they can fulfill their very specific intents, specific use case, sorry. So I believe it's still early. It may happen maybe 10 years from now or 20 years from now, who knows. But still we have a long way of innovation and discovering what is the best possible model that we'll be building. I think this will take some time.
And at the same time, it's kind of feels wrong from the point of view of like an open market to dictate how like the application should kind of deal with these intents or kind of order structures, because it would be like as if suddenly like, I don't know, the internet market tells like all these internet companies how they should optimize their servers in this way, or they're not allowed to actually, you know, play the game. So it's like, why would an open market say, I have to treat this in this way? Unless there is an infrastructure point of view that then you're like, okay, because, you know, we kind of verify or trigger the transaction in this way, like in the internet, no, HTTPS or TCP, like it just works this way. And you have to figure out your architecture around it. That's it.
I think the biggest reason for, really like, I mean, we started thinking about intents like 3 years ago kind of thing. And I think we were by far the first. I think like a year later, the next sort of wave of people started thinking about this. And so generalized intents are just coming. I think this is sort of the biggest takeaway. But the one reason why I'm pretty optimistic but that we'll see sort of a convergence in the architecture is because you defragment the liquidity, especially on the trading side, right? Like if every application ends up having its own standard, this is fine, they can live at the same time, but most likely the actual generalized standard will win or like will propagate long term because it can provide better pricing to users, because users now don't have to decide what specific application to trade with, but rather can decide where the best price is. Like users can effectively say, I don't care whether I'm on CowSwap or 1inch or something like this. I just care, give me quickest execution, lowest latency, lowest cost, whatever, right? And so this is, I think, the really strong argument for why generalized intents would actually be, like end up providing better UX to users in the end.
Yeah, that's pretty good.
And just to add on one thing you said, like on the fragmentation liquidity and like how with the standards, we haven't been able, like within DeFi, to standardize one stablecoin. How many versions of USD is there out there? And yet, it's the most simple thing, right? One stable, I don't know, 2 stablecoins.
Yeah.
There's
why not
10,000.
Yeah. No, that makes sense. What are your favorite use cases for intents apart from orders, swaps, and trades?
Scale-free money. Scale-free money. It's,
what do you think could be like an emerging use cases? Because most people, when they hear intent, they just think of this, right? But they're more than that. So
payment, that's a pain point I had personally when I receive USDC and I want to use it, and it was a big hassle because I need to load my wallet with gas and which wallet I should use. Once I had to do an on-ramp, which is not very DeFi at all, but yeah, just to get the gas. I think for payment, that should be something like a big use case that will should be seen in the future. Anything that abstracts the usage of crypto to the masses, that they don't care about how the backend works, like how the complexity of the magic that is done on the backend. They just worried about pushing a button, like worried about their use case. They just want to push a button and get the stuff done, and they don't need to know more. Makes sense.
I think the other really big use, like it's outside of financial assets. It's like, because generalized intents effectively just just have this idea that you outsource compute, right? Like you may outsource compute over trades, but you can also outsource compute over other things, like ZK proofs. And I think so intents will actually end up being a lot of about how do we outsource compute to third-party solvers in a way that is very dynamic and flexible, so that individual users can make choices on sort of who they actually trust here. And the other thing is, as soon as you start having this like outsourced compute, you can start building models like scale-free money, where it's like, well, I may be like 15 hops away from the next person that I actually want to pay, but there is a path through the system, and I can pay someone to figure out that path, rather than me having to figure out how do I transfer between all decentralized things or decentralized things. Just like I have X and you want Y, great. There you go, and I'm paying like 5 cents for that actual cost.
I think the good use case is cross-chain operations, when you can issue an intent on one chain and some professional can execute it. And for example, the same bridging, like to give you a token on the one network and receive your token on another network. That's pretty good use case for the intents.
Does from the audience, people have some question? We're at the end of the panel. Yeah, I think we're good. Thanks for giving such insightful information.
Okay, so that was the last talk this morning. So we're back at 2 p.m.
So, right before your talk, if you want to stop in here, I can let you take this one over there, and then I need it back afterwards.
Yeah, and this is Bluetooth or how does it work? It's working with this?
Yeah, I think so.
Man, I wish there is one.
Yes,
that
they have
you
a
don't
simple.
need. Yeah, that you don't need. You know what?
Thanks. Hello, everybody. We are having some issues finding our current speaker. We do have another speaker up at the bottom of the hour, and we're trying to find someone to fill this other person's space. So hang in with us. Step on that computer and let's plug this in and see if we can get your screen up. Can you simply mirror your screen? Can we get him hooked up real quick?
Check, check.
Okay. Yeah, I'm gonna let him go for 15 minutes. Yeah, if not. So when we're about a minute out, like I'll just go ahead and raise my hand. If the next guy is like doesn't show up on time, and I don't raise my hand, just keep going. Well, we'll see what happens when we get there. What about the next guy? At the bottom of the hour. Does he look like he's
This one? It's full?
No, the one at 2:30.
2:30? No, it's
Take your time then, man. No rush. Okay. There's your microphone. Wait, is it? Yeah. I'm not going to introduce you because I don't know anything, so just go ahead and introduce yourself. Can we get his...
Hi, everyone. Thank you for joining this session. I just jumped in because one of the speakers didn't show up. My name is Sándor. I represent a company called SolarPunk. Some of you might have met me outside. I think this is a great networking event. I hope that you also had this experience. I'm going to be talking about NFTs and how to properly store NFTs on Ethereum. Once the slides are up, then I will get started, but maybe until the slides are coming, I'm going to just introduce myself. I have 20 years of experience in software development, and I really enjoy the time in Web3. Just joined a year ago, so relatively new. But I think there's like a silent revolution going on in the technology space right now that we are part of. And I think the key is decentralization. Because I hear a lot about blockchain and NFTs, but I think that the key word should really be decentralization. And one of the aspects of my speech today will be decentralized storage networks that I haven't heard a lot all through this conference. And many of the technological or architectural designs presented were not containing any decentralized storage, which is, I think, a miss.
We're having a technical difficulty getting your slides up. But once we get them up, you can take as much time as you need. This happened in the other room a few minutes ago. For some reason, when we hook another computer up, like all hell breaks loose. There we go.
Thanks very much for fixing the slides. So welcome to the proper treatment of NFTs on Ethereum talk. My name is Sándor Nagy. I'm the CEO of SolarPunk. We are building Web3 solutions, mainly focusing on the usage of decentralized storage. I brought you one decentralized storage. Some of you know this already, as we had discussions on the corridors. This is Ethereum Swarm. And I'm going to be using this in my example solution today. I brought you a problem which was raised a few years ago, and I'm pretty sure many of you know about this. If you haven't heard about this blog, the issue was raised by Moxie Merlinspike. He is the CEO of Signal, and he made a little bit of a joke of NFTs, and he just wanted to raise awareness that in this secure blockchain world, we are using NFTs in a way that you have no guarantees on what you're buying. Basically because NFTs contain a Web2 URL. And he created a sample application where you purchased an NFT. It looked like this at the beginning. Or on one of the NFT marketplaces, it looked like this. And the other one showed a different image. And then later on, the first one decided to ban it and removed it, which is not really acceptable in a Web3 space, in a decentralized era, where we are aiming for censorship-resistant systems. But what can we do to ensure that our NFTs, the content, the digital content that you created or you paid for is gonna stay where it should? By the way, who has NFTs? Okay, anyone minted NFTs? A few? Great, okay. Any content creators, maybe? Oh, cool, hi. Yeah, on the, I just came from the New York NFT conference where I presented this speech, and there were a lot of content creators there, and many of them are not aware of this problem. They just want to have another marketplace where they can sell their artwork, and often the underlying technology or issues with the underlying technologies is not really noticed or highlighted. So what requirements do we have to create a system where our digital content that is associated with an NFT that we pay for is not going to just disappear? First of all, we need proof of ownership, because in the previous example, I could not prove what I paid for. So this has to be fixed. The next thing is integrity protection. If this audience is a little bit more technical than the NFT one, so I will tell you a little bit more technicalities. So if you have a text file and create a hash of it, you get a code that should not, a hexacode or number that should not change until you modify the content of your file. So integrity protection is very important, because then you can check, you can verify that your content has not been altered, has not been modified. Guaranteed availability is also a factor, and permissionless access. And also it would be great if there was some sort of guarantees that your digital content that you paid for is going to be available online. I'm going to be proposing a solution using Swarm decentralized storage, where you can see these rectangles here representing an asset stored on Swarm decentralized storage, and the storage proof, which is called postage stamp in Swarm. And then based on this, if this information makes it to the minted NFT, so if your minted NFT has a hash that provides integrity protection of your content, and also has a proof what you can verify that your content is going to be available online, then we are in a much, much better place than today. And there is one special aspect of Swarm that I want to highlight. If you check the NFT upper rectangle now, there is a hexadecimal number, which should be the integrity protection or the hash that provides integrity protection. And the special feature of Swarm is that when you upload the content, you will get a hash of it. It's going to be immutable, and also this hash will be the address of your content. So using this, we can easily establish a convention-based approach, either using a website, using a gateway to the decentralized network, or even better, if we can be part of the decentralized network simply by installing a version of the Swarm node on our laptop, and then we can view the content. So I want to show you an example. Hopefully I'm not going to break the tech side of things here now. Oh, cool. So what you can see here is the local node running on my computer, on my laptop. And you can see an image that I uploaded here. And also, I will show you the hash that has been generated for this content. And if you see the address, it will also contain the generated hash. So that's the local viewing option for you, using being part of the decentralized network. And the other one is using a gateway, where you can also access the content. And again, the hash of it will be an address as well. So let's go back to the presentation. Okay. So with the previous solution, we have proven ownership, integrity protection, we have access on a decentralized network, and it is permissionless, and also we got persistence guarantees. Oh, actually, here is the example that I wanted to show you again. So we saw that, so I will skip it now. This convention-based approach has one problem, and that is the NFT marketplaces. If they decide not to support this convention, then your NFT is not going to be visible on OpenSea or any other NFT marketplace. So if they decide not to go with this convention and not to accept our suggestion, we are in talks with OpenSea about this, then we can create a DApp which would help to generate metadata and also check the storage availability and make your NFT available as well. And also we can generate a metadata that, of course, matches the standards, and then this way the NFT will be available on OpenSea or any other NFT marketplace. So just want to emphasize again that today it would be very, very important to get to a stage where NFTs at least have a hash, an integrity protection, or a way to verify that the content that you purchased is not, has not been modified. I've been talking about a simple example of NFTs so far, where there is an artwork, digital content, and nothing more to it. But now let's look at dynamic NFTs, where utility trades, club memberships can be handled, and different types of rewards can be given. Swarm can help with this as well, because there is a feature in this decentralized storage which is called feed, and the feed provides dedicated URL to you, and you can post and modify your content, which will trigger an action of creating new content, because the decentralized storage is immutable. And this way you can have like a posting feature in a way, or you can keep versioning of the changes that you make to one single digital content file or anything else. So this allows us to create utility trades. So for example, the publisher can post, let's say you're a member of a club, and they decide that this week if you visit the club, then you will get a beer, and then this could be added to a Swarm topic feed. The DApp that I mentioned earlier can generate the metadata, and it can update the NFT, and also let the user know that if you go to the club this week, you will get a free beer. So that was my speak about NFTs and the way we store content associated with an NFT. Do you have any questions?
Anyone have any questions? You raise your hand.
Hello, thanks for the talk. So if I want to make my kimchi collection of NFT, kimchi dosh, and I have an option between IPFS and Arweave and Swarm, like how would you say Swarm is the best among those three? Like, what kind of advantage would Swarm give? Because, you know, basically we can do everything with IPFS if I'm lazy about not changing.
Yeah, I think the most well-known decentralized storage is IPFS. The only problem that we hear from some of our new clients that used to use IPFS before, they say that it's not really decentralized, or there are options to use IPFS in a way that is not decentralized at all. I don't know the second.
You want to reiterate the second question?
So I cannot reflect to that one. Sorry.
Oh, you just can't answer the question, or did you want him to repeat it?
Sorry?
Did you want him to repeat the question?
No. I'm just saying that I don't know the. I'm just saying that I don't know the second decentralized storage provider, so I cannot, you know.
Okay. Someone else had a question over here. He had the same question.
Okay. Yeah, it comes up very often. That, what is the difference between IPFS and Swarm decentralized storage?
Anyone else? All right. Thank you very much for filling in for our speaker that didn't arrive. Great presentation.
Thank you. Thanks. Good. Thanks.
It's Miko, right?
Yes. Thank you so much.
I'll give you a minute. So we're going to take just a moment to make sure that they're prepared, and we'll be right back with you.
Yes, I think if you need it, I can use this one as well. Maybe it's even better. Maybe, but can you check that it works? Because now I see it's not a mirror. Allow. Oh, continue. But maybe. Stop mirroring. Can you check that it works?
We are going to.
Because it doesn't show anywhere.
Yeah. Okay, so
yes,
I think
so I can play. Here it works.
And does it work?
Yes.
Oh yeah.
Oh yeah, perfect.
Perfect, thank you.
One.
Miko is the inventor of Gearbox Protocol. He'll be speaking on Gearbox and his Gearbox DAO that manages risks, interest rates, and more. Welcome, Miko.
Yeah, hello. Hope you're in a good mood. I think it was a very productive 2 days. So now, if yesterday I was focused more on technical details related to things like how to make protocol robust, how to update it, and so on. In this case, I want to talk a pretty interesting topic from my side related to how to make the protocol scalable. And at this point, I believe many other protocols who really try to solve the task maybe sometimes fail, maybe sometimes was successful. But what I've learned from the previous 3 years was about how to use a technical strategy. So I'm not willing to talk about marketing, how to do this and so on, how to really support protocol growth from the technical side. Hello one more time, my name is Mikhail. I really started from the hackathon, so it was like a true story. Gearbox was invented in 2021 January during S Global hackathon, so I have no good connection network and so on, and today it achieved yesterday $400 million. So it was a pretty good achievement here, I believe so. And what I've learned from these 3 years, making a lot of mistakes and all this stuff, and how to really make this transformation, I want to talk. And initial idea of Gearbox was pretty simple. It was margin trading on Uniswap, because margin trading is always a pretty interesting idea. But of course I started thinking, okay, I'm not willing to attract liquidity. It's a lot of different job to do a whole exchange. Can I really use Uniswap just for trading and so on and build something upon it? And then Gearbox become very flexible, and now we can leverage literally everything, any protocol and token. And just a short recap what Gearbox is. Gearbox works as a decentralized prime brokerage account. So basically, you can consider it like a smart contract wallet when you have X10 more money. But you could not do whatever you want with this money. You couldn't withdraw into your pocket or do anything. Instead of that, you can go across of different protocols, get the leverage, and really support your any strategy in the most natural way. So there is nothing to learn how to combine two different protocols and so on. It works similar like you do it in real life. And a short recap how it works. So basically you can see there are two sides of the protocol. On the passive side, it works like a normal bank depositor. So you can really provide your money on the left side and get yield. And you should not really check Twitter all time and understand is it good or not, because I'm the worst trader ever. Which assets I bought, they also going down, so I prefer to be on the passive side. But at the same time, I know that crypto generates a lot of money. I am not willing to put my money in European Union Bank to get 1% API. I want to get some share, and this share of the yield should be in a fair way. So all these 3 years, we focused to make a very good terms for LPs. So when you deposit your capital on the left side, it goes to the pool, and that's all. Then you can take your LP token and really get the profits. But what is really unique in Gearbox, it's the right side. And this needs these people who are really checking Twitter and know how to trade and make money. So they could open a credit account. It's a DeFi primitive which was invented 3 years ago. And the logic here is that when initial funds are transferred on this credit account, it could take leverage from the pool. For example, Nidzias could provide 10 ETH, then it takes 90 ETH from the pool and it's get 10x more money. And then each transaction which sent by Nidzias, you can see it here, goes through a special credit manager, which checks all stuff and so on, and then it executed on behalf of credit account on third-party protocol. So pretty easy. It looks like you have 10x more money, you send different transaction, and then you can really deposit this into different farms, restaking, or, for example, you borrow USDC, then you go to Uniswap, swap it into ETH, and you already have a long position. And the good point that we never know what would be a really successful in the next years, because the biggest problem with all DeFi or any kind of crypto founders that currently you can have an idea, wow, it's good to build a margin trading. Then you start thinking, you spend around from 3 to 12 months on development, because crypto, to make it safe, it's a pretty hard. Then, of course, you should pay for audit, and it also takes around 2 months. Then you deliver it into production, and it's too late. And it's a huge problem, what I've seen for the last 3 years. Deliver it to the market and go to the market. It's a crucial stuff which you should support. And definitely people, as you know, who start and switch to restaking make a huge access and a very successful project. And the question, what we start thinking in Gearbox, how we can build a system to deliver any kind of leverage extremely fast. And what we found, so basically you can see, it's a very good date. It was on the 20th of February, we had leverage restaking points. At this date, we really first add Renzo ETH and Etherfi and so on. And you can see how fast it starts growing. So basically, what you should do, it's by design, by technical design, make your architecture very, very, very generic. In Gearbox, we have a lot of complexity. I talked about yesterday. It's related that we can support many protocols. We should build some intermediary contract, which is called adapter. But the basic idea here, through this complexity, we can really add leverage for restaking, for farms and so on. And each new protocol which comes to the market and have a very good, at least provable price oracle could be listed on Gearbox. When you can do it faster, the first outcome and first insight I got, when you can do different things pretty fast, it's a good way to fast growing. And when you develop your architecture, do not try to hard code any concrete protocol. I really met a lot of people who built something and they said, hey, we really want to leverage or do some operation with this Uniswap pool. Keep in mind, maybe in a few months, it will be outdated. And if you could not switch to a new idea, it would be too late. Another part related to, I think it was a really great innovation related to the quota system. Gearbox introduced it the first in the market. And basically it's another part what we learned for 3 years. Some tokens has low liquidity. Some protocols are not so mature to get leverage from big protocols like AVA and so on. How we can make a really system which could help us to make them also with leverage, because it's also lucrative yields. All risk could be really transferred to there. And we create a really pool-centric way when you can set up precisely limit of collateral. So here you can see, for example, for VEs, we allow to use not more than 20,000 Ethereum as collateral. We never compute these things in token you provide. We always compare the pool. And this quota system makes a pretty good way, which I've never met before. Because now the pool has a different limits. Not more than 10% could be invested in asset A. Not more than 20% another would be used as collateral for asset B, and so on and so on. And then when you go to the pool, you can combine some very risky active, which could generate some yield, with low risk things which could generate more stable outcomes. And I think it's a good innovation. And another part which is pretty cool, we create rates for any asset you really could use for. So basically here you can see, if you go to VEs, you will pay additional 25.87% to the pool APY. And it's create a great utilization. So at my point, many protocols try to say, hey, we have a high TVL. It's not a metric, because utilization is a real metric which we should focus. When your protocol has a lower utilization, it means that on this borrow side, let me go, oh, sorry. If you have a low utilization, all money which generated here will be distributed for many idle liquidity, correct? Yeah, so this part makes money, this part gets the APY. If your utilization is low, it means that all this money, for example, it's 10%, will be distributed for all pool participants, and the end rate will be like 1/10 of borrow rate. When your utilization, like in a Gearbox, around 90%, it makes that all dollar earned here will be converted to 90 cents here. And it's a totally different way how high APY could be achievable in the pool. And if you go here to the quota system, it's a very, very good idea to have these quotas, which could set us, not by us, by a special gauge system, different rates for different assets, and create a really fair distribution between LPs and people who build strategy, because it's a market equilibrium. If people today are willing to pay 25% in Ethereum to get yield from a risk-taking protocol, it's a fully market way, and we shared it carefully with LP. And this rate do not depend on pool utilization like in many other protocol, and as a result, it's really help us to avoid the spiral. When, for example, rate is going down, people start to close their position on the right, then the APY going lower on the left, then people start to close their position, and this spiral totally destroys the pool. Gearbox, luckily with this quota system, I believe they will be implemented soon in many other protocols, are pretty safe for these market fluctuations. Another part, what I also want to tell how to make your protocol scalable, and it's a very, very significant, is smart contract UX. Primarily, people who develop their products do it's totally in two different ways. The first part, they start thinking about how to build smart contracts, and then they start thinking how to build a front end. And the problem is that sometimes in the front end you should do multiple actions, or what is much worse, you ask people to go somewhere, for example on Uniswap, do this stuff. In Gearbox in 2022 we implemented a multi-call, and now you can build a complex strategy in one click. Just imagine to do something. Add here all required approvals. I will talk a little bit more, but it's how you can also improve your protocol in terms of growing, because one click makes a lot of sense. To open a convex position in Gearbox, you should do, and it's like the easiest way. For example, you borrow one ETH somewhere, so you should go to Uniswap and swap. Add one more transaction to get approval. Yeah, it's as always. Then you should go to the curve if it's the good pass and swap 3,200 USDC into frax. Also add some transactions to approval. Then you should go to the curve and call add liquidity to get this LP token. Then you should go to the convex. And then of course you can, something in the middle, really lose some money because prices are going up and down. And if you ask your user to do some much complexity to get something, you really have a very, very low conversation. We built multi-call which could execute this in one transaction, do all needed approvals, and for safety we remove all of them. So after that, in all these protocols, we will set zero allowance. As a result, people will really very, very grateful that they could open any transaction in one click. If you build your own protocol, do it on smart contract level. Do not really give this to the front end, because on front end, the majority of this stuff could not be done, because only user has an access and take all stuff. Another part, what I've learned, that approvals and permits, it's an also huge barrier. All time when I personally go to DeFi and want to do something, it's an also really pain when you should go approve. Some tokens like USDT requires to make a zero allowance if you want to raise it. So it's a very, very bad UX. If you can build something which do it automatically in your protocol, you can grow much faster, because you really, each time you ask user to wait like a few minutes when transaction will be submitted on chain, it takes so much efforts, and people are really prefer to switch somewhere. Crypto is an economic of attention. So keep this attention and focus on value, not on this continuous operation. And today I want to talk some more ideas what we can build more to make protocols even better. So in Gearbox, as I said, we built multi-call to create a seamless UX on the smart contract level. We make it modular to really get stuff related to add new assets and really create the market what user wants. But what we can improve, I have some ideas in mind, and probably some of them will be implemented in the next version of Gearbox. The first part, I'm really happy that a few weeks or months ago, this EAP for 4844 really happened. It's a huge improvement for the whole Ethereum ecosystem. Just imagine, when you built your protocol previously, we do all these tricks for gas savings. All lines of code were rewritten. You take different tricks how to compute in a more efficient way and so on. Currently, gas prices are really nothing on rollups. Just check, it's even not 1 cent on Arbitrum One to swap tokens. Now, I think the new era of developers are coming. It's my prediction. But definitely we should not focus so much on a gas. The same things was in Web 2 when the web servers came to the scene, and people also, because it was a very low machines, tried to optimize their code in C language and so on. And then of course, when we have a like zero gas cost, I believe definitely the complexity of all protocols will grow, because now you should not focus on this low-level development. You can do much more. And pretty soon, maybe in a few years, we will get Solidity frameworks in analogy, like we have a Web 2 frameworks, if you know Express in Node.js or a Python framework, which definitely improves the system and the way how fast we can deliver. And following this, I believe this complexity will be encapsulated in some frameworks, contract size will be included, and we could deliver faster and much safer, because now we should not really think, should we add this check or not for security. Another great part was APE 3074. It was not so far away, and the account abstraction. And it creates a new opportunity to Gearbox will be much closer to the user. Keep in mind, now you should go to Gearbox if you want any strategy, click something and do anything. I definitely want to remove this intermediary change. Why should user to go to Gearbox website for operation if it could work like a credit card? Credit account is already thing which is developed as smart contract wallet. It's what we have at the moment. Why we could not really connect it on the wallet size as a backend and allow you to open your MetaMask, Frame, Rainbow wallet, which support credit wallet abstraction, and has just extend more money. And then you will be so natural like credit card, because nobody cares how it works. You just go to the shop, use credit card, and it's done. And it's a future when we really create amazing composability, because people now are not focusing how to really jump across different protocols to build your strategy. We can be easily integrated on the wallet side and make a natural stuff. And another big stuff, if we can really achieve that, if we can really build a wallet with X 10 times more like a credit card, the next part what we need is to be more decentralized. And here I believe it's my also prediction, and it's also common, that we will get a totally new companies or protocols who can like chain link stream their risk parameters. It's also happened with B protocol. It also comes from Gauntlet and Chaos Lab, some of these ideas, and it's a pretty cool. If there are some people who knows or at least predict and do some risk job, and it could be really streamed like a chain link stream prices on chain, it's verifiable. I can check historical predictions and understand who really makes this risk prediction and settings for the protocol much better. It could really be qualified and maybe some extra payment. I have no clear idea how this business could work, but it's what we will come. And then you on LP side could really choose this risk provider as you want and deposit your money. And there, what I believe could be like an end game for Gearbox. What we are going for is to become a liquidity layer. Just imagine, to simplify user interaction with the protocol, we definitely distinguish two parts. The first part of Gearbox could be simply integrated in the wallet level and work across multiple chains. So basically, you should not go to any website. Gearbox or any other leverage things could be implemented in your wallet and just provide money wherever you need. It could be done on RFQ like Intents, it could be done with additional action, but you should not really check all this front end and so on. And another part which delivers this capital to liquidity layer like institutionals and so on could pick pools wherever they want by risk provider. Because if we can really have in an industry pretty robust risk provider who can make all this good risk prediction, there is no way to trust the protocol. If you are institutionals, you can trust the risk provider, to person who care about risk, and here you should really have a battle-tested solution, and that's rollup, but it's okay for me to deliver this liquidity to be used on mainnet, and this rollup, and this rollup. And that's all. You choose your risk profile, your liquidity is provided to this liquidity layer which exists cross-chain, and then people who is going to this chain, they just open their wallet, get credit account, and do each strategy what they want. So what I believe, And what we should really focus is on the solution which really improve the UX for the end users. And this solution looks pretty simple because risk providers do not ask you to go deeper in such a pretty complex white paper and so on. It's on-chain verifiable, so reputation could come somehow. Cross-chain contracts will be battle tested and audited, which also make it much simpler for LP to choose whatever you want. And on user side who use leverage, these things, when the leverage is accessible through the wallet, create lower barrier, which also create a better interaction. But of course, it's such idea, we need to do a lot of things ahead, not only on a Gearbox protocol, of course, the whole industry should grow to this level when we can definitely improve user interaction. Basically, it's what idea about the future, how it should be for end users and so on I want to share. Please, if you have any questions, I'm ready to discuss. Thank you so much for attention.
Thank you very much. So do we have any questions right back here? We got a few.
Hi, great talk. You mentioned something about automatic approvals and permit. How exactly did you manage to make it automatic?
I think lending pools, can you return the picture, please? Yeah, thank you so much. So basically lending pools, what I said here, should be really changed into two parts. The first part is liquidity layer. And basically, of course, at this wallet, it's not only one idea that you can leverage to get something. Of course, you can also get the solution from your wallet. Because currently, it's pretty strange that you should go to the protocol here to any website to get it, if you can do it in your wallet. And currently, if you have any normal digital banks, you can do a lot of stuff in the application which represents wallet. So taking on-chain credit or leverage from the wallet layer, I think it's the most natural way. So basically, I believe other lending protocol will also follow this narrative and also be closer to end users.
Over here.
Hello, thank you for the presentation. So, my question is about the liquidation. So, do you have an open source liquidator? So, for example, can I join your liquidation program, or do you run all the liquidations by yourself?
Yeah, thanks. It's a good question, and basically to talk how it works, I can go. Oh, yeah, this part. We have liquidations, of course. If you consider here, this credit account works as smart contract wallet, and it means that all tokens on this credit account are considered as collateral. So basically, if health factor, which is simply a ratio between the value of collateral downgraded by LTs to your total debt with interest rate less than 1, such account could be liquidated. And in this part, it looks that simply a risky asset will be swapped back to underlying one, and the debt will be paid. It's already how Gearbox works. And of course, this part should be also improved from UX side. From my point, it's very, very bad things for end user when it was liquidated. So basically, we really now working on the leverage bots and other solution to help user to avoid any kind of liquidations. But if it could happen, it should happen to really protect LP side. So basically, in this case, I think the improvements for scaling what I'm talking today, how to attract more users, would be focused on two sides. The first one, make all tooling like limit orders and so on, to avoid possible liquidations. But if liquidation is needed to protect LPs, it should happen, and in this case, it could be really pretty high things like it's totally normal like in Maker. Yeah, I think DAI liquidation takes 13%, which extremely high, but Maker is stable. So basically, we should protect LP on the first place.
Any other questions? Or did you want to keep going? Anyone else? Going once. All right. Thank you very much.
Thank you for your attention. Have a good stay in Dubai.
So if you want to give us just a few minutes before we start the panel, we'll be right back.
Awesome. So we need four mics.
So we're going to go ahead and get started with our panel on DeFi and the risks involved on using tools for automation. If we want to go ahead and bring the guys on the stage, we got microphones up here. So coming to the stage, Sarang Parikh, we have Miko ETH, we have Eugene Chen, Moody Gupta. Am I forgetting anyone? No, that's it? Okay. Yeah, Clement unfortunately couldn't make it due to flooding issues. So I'll go ahead and hand it over to Sarang, and if you guys want to take it from here, thanks a lot.
One.
Yep. Hey guys, how's it going? So hey everyone, like we're going to talk about leverage, right? And it's a wonderful presentation.
Thank you so much.
It will carry on the flow for the audience as well, right? So let's start with a small introduction and what do you do? Like what does your product do? And what do you think is leverage and composability? Is it like a curse disguised as a cure for DeFi? Because what other hacks we have seen and everything, like what is your opinion? So I'm going to start. I am Sarang. I used to lead engineering at SushiSwap. Now I'm an advisor. I help out other projects. And for me, it's always been a cure. It's never been a curse.
Hi everyone, I'm Eugene. I work at Ellipsis Labs. We are contributors to Phoenix, which is a limit order book spot DEX, no leverage, on Solana, currently doing a few $100 million of volume per day. I find leverage very scary. It's very difficult to get right, but it's clearly something that's demanded by the market.
Hey folks, I'm Madhur Gupta. I lead security at Polygon by day and Degen leverage trader by night. Leverage is basically like the quote comes to mind, with great power comes great responsibility. It can wreck you, but it can also be very fun if used correctly.
Yes, I already have a speech. So my name is Mikhail. I am original inventor of Gearbox protocol. We're making this composable leverage. And from my point, leverage, what is very, very significant, brings capital efficiency to the industry, and efficient market always a good public value for everyone, because more efficiency means more money, more safety, and so on.
Yeah. So that brings to my next question. With efficiency, it comes like capital at use, right? And there is this leverage debt cycle that people keep leveraging. Like what do you see with Pendle, right? Like you have multiple folds of actual leverage to get that point. So like when Pendle actually started, like it's when it had the first PMF was when it takes Rocket Pool ETH, it deposits into Balancer, then Balancer deposits into Aura, and Aura then deposits into Pendle to get that, all that leverage yield, right? And that could really turn into as disastrous any one of the, building blocks fail. So when do you think is like a stopping point, or you should analyze, okay, like is this leverage risk worth it? And how do you analyze it? Because now there are multiple fronts for the attack, right?
I think leverage is always risky and should be done by only professional players. And it's how maybe current markets exist everywhere, because basically crypto is not mature at all, and people who have some experience or knowledge could go through the leverage. And of course, we should build these risk frameworks to make it safer, to better do all risk management and provide all needed information for decision making. On the other side, just imagine with leverage, you can really help pretty good protocols grow faster and deliver value faster. So you are great to talk about all this interconnectivity. It could be a systematic risk. It's why we really need researchers and scientists to build a robust frameworks to compute and do it on the mass approval side. But what I really like in crypto is that everything is transparent. You should not trust like any centralized exchange and their reports. You can do your own research through the Etherscan. It's amazing. So do not trust. Leverage is risky, but you can check everything on chain and make a decision with the whole information in comparison with all other financial systems.
Yeah, for sure. So more direct to the question, like with Pendle and most protocols as well, like it's leverage is all about risk-reward ratio. You get more reward, but there is more risk. And the risk, at least in my opinion, and even in the market's opinion, wasn't worth it till points came in. And once the points came in, the reward just shot up while the risk remained same, and you saw a boom in usage for all of these protocols which were providing leverage. So yeah, leverage can be good when the risk-reward ratio is good. It's super bad when it's bad, and it's up to the market to decide.
Yeah. There's like a bunch of different forms of risk, and I think one of them that we think about from the user perspective is I put my money into some leverage protocol, and how likely is it that I get liquidated? And then there's other form of more systemic risk where supposing everyone has their liquidation points all at the same place, like everyone exactly 10x levered on some cursed like restaking ETH 10 times over, and everyone gets liquidated at the same time. What happens to the whole system? Like, do the protocols themselves go insolvent? And this is going back to your point on transparency. If everything is actually fully on chain, it is possible to monitor and detect these types of things. There still are a couple problems here where, like, one, there's not too much of an incentive for someone to go out and do this. It's kind of this like thankless work. There are some folks who do it for free, like the Parsec guys, for example, always have these great dashboards around liquidation levels on Aave and other leverage protocols. But I think the leverage builds up faster than dashboards can build up. And there's also this incentive misalignment between the developers and the users where, yeah, if I'm just starting out building a new protocol, I may be incentivized to give my users much more leverage than what is going to be safe for the system because I'm trying to juice the TVL and gain some attention. And that problem worries me a lot more because I don't really see any tractable ways to fix it.
I think that's getting worse because now these new protocols have points, which gets levered. I tried to pay people in points, but they just don't accept it. I don't know why. But they keep on going on Pendle and farming. So, yeah. But yeah, that brings me to the question, right? Like, so you mentioned the factors that could, have systematic risk based on your protocol, right, and how your protocol functions. But there could be more factors which probably might not be in your control. Let's say what happened to, I think, like Hyperliquid, like few days back, like that Oracle issue where they had to, some of the position got liquidated, or there's issues at some chains where they stop for some time and they have to resume it back. And that for leverage protocols, it's almost very bad, right? So how do you think like people should build leverage protocols in a way to be sustained? Because you can't guarantee an almost uptime for almost all the new chains, right? So maybe as an app dev, we have to be careful about how do we build it. So if you guys have some thoughts around it.
I mean, I'm an application developer, but our product today is 100% spot, so we don't have to worry about any of these leverage issues. So I'm kind of, shouting from the bleachers here. But there's a bunch of things on the infra side, and really just any dependencies that your protocol has, whether they're on other assets. You sort of care about their return profiles. You care about how safe the oracle that you're using is, and you need to be able to model all of that type of risk. You care about things like the chain going down, and it's pretty easy to model these things like independently and reason about them one at a time, but actually they interact with each other in these very weird ways, where sort of all of these tail events tend to happen at the same time. So for example, if some blockchain that has a leverage protocol, the blockchain itself goes down, some other things you might expect to happen are like, oh, the Oracle update is going to be stale. The Oracle update, the next one is probably more likely to be inaccurate. The volatility that you expect during the time when the chain is down, you should expect to be significantly higher as well. And these things are all just super, super correlated. And if the goal is to design a protocol, leverage protocol that's going to be robust to all these things, you need to be robust to all of them breaking like exactly at the same time. You need to be robust to other people coming in and using your product in a composable way to like maximize the risk involved or like maximize the degeneracy involved. And ideally, you can be robust to that too.
You go ahead, tell us how the Gearbox does it.
Yeah, I think it's L2s. You should assume that there is more infrastructure risk, as you said, that L2 could be blocked for some period of time or do not respond and so on. And here I believe another interesting part, what we already told, is how we can throttle this L2 when it comes back. Because it's a very, very interesting problem. You have a state, and this state is frozen for many, many hours here. And then L2 comes back to life, And in comparison with mainnet, for example, it's a huge price difference. If you allow users to make one trade for the arbitrageur, to take the all profits, to sync the levels between mainnet and L2, it means that these guys get unfair profit. And if you have a sequencer, maybe this profit could be shared with sequencer, but all other users could get losses. And here probably maybe on the protocol level or sequencer level, we could find a solution how to throttle these networks to get equal access to the capital when it will synchronize the prices between frozen L2s and real market. And it's like a technical problem, but probably if we could build this in a more robust way, it could reduce the losses and do not make like a huge profits in one arbitrageur hands.
Yeah, I think like most sequences are centralized as of now, right? So this can be done with much effort, you know.
Yeah, but like at the same time, there's more effort being put on decentralizing these sequences. So this would be counterproductive in that sense. But like if I was developing a leverage protocol, like I would build something like a heartbeat. So that means like the protocol would kind of just stop trading if there is no heartbeat from Oracle/liquidation agents, and you can then have still time-based price feeds. Like whenever the chain comes back, the Oracle would still feed in the prices with the relevant times, and the liquidator would liquidate at those price points. So it does add another component and potentially a bit of centralization risk. But if you can make it like a decentralized network sort of with like, for example, how chain-link agents are supposed to work, then it can work out.
And I wonder like how many of the protocols actually do that. So it's also a question to ask when we actually use these protocols, and there's a real risk, right? And if these protocols do that, if not, then they should adopt to try to do something like this, So yeah, and there is other kind of risks, right? Like now, when we've talked about like oracles, right? So all of these leverage protocols want to have as many assets as they can, right? But that comes with a cost, right? And not even just small one, but big ones as well, which take up like a very high position, such as what happened with Aave and Curve saga, right? Where Aave had a lot of Curve exposure, right? And in that case, like, what can be the ways where you can avoid getting into this situation? Or how could you as a user be informed on, okay, like this token doesn't seem that liquid, right? And even when the Terra thing happened, like the liquidity just got pulled off the curve, right? Sometimes you might not even know. So how do you get this with the shared risk versus the isolated risk in leverage?
Yeah, so, I mean, the reality is 99.99% of the users don't care / don't know how to even care about this. And that's why we really need the protocols to have like a security council or leverage council or governance or whatever you want to call it to handle these parameters. And it's the standard in this industry, like vendors like Gauntlet, Chaos Labs, Chain Risk, all of these are like, it's their job to like help set the parameters correctly so protocols can't like don't go in bad debt risk like this. Obviously, like Gauntlet didn't manage to pull off the perfect job with Aave, so we got in this situation. But like it's if they can't do it, we can't expect the user to be able to do it. So we just have to have professional people actually managing risk there.
Yeah, I really like the name leverage, like a team, like, or like leverage council. We can just drop the lev and just call it rage council. I think that'll be better. But yeah.
Yeah, from my point, I can't agree that any leverage protocol want to maximize the quantity of assets. I believe each leverage protocol wants totally the opposite. At least in Gearbox, my point was always, we want to pick the best ones to generate high yield in a safe way, because we should not have 1,000 different assets and really have high risk. We want to pick what really users want, and then we kick them out all other stuff, because basically if no one go to positions, there is no reason to keep it in your protocol. You can simply delist or set the lower limit and so on. And what I already told, with the quota system, we can really make it very, very flexible how much collateral we can use for any particular asset. It's a good point, but here I definitely believe that users could vote what they need. The leverage protocol should provide what they need, and the key metric for any leverage protocol is utilization. It means that you really give required asset with correct limit, and I definitely agree that professional risk players like Chaos Labs, we are starting to work with them, I think in a month or so, could really focus on all these parameters to make it safer. But please do not add as many as you can. It always under control, and consequences could be pretty bad for anyone who wants to add whole market to one protocol.
Yeah, I really like the giving the power to the people, like, for voting. My next question is going to be based on that. But if you want to add in something,
I really don't have too much to add. I think those are both good answers. I'd just like to reiterate that it's pretty unrealistic to expect the users to do all the risk management here, and there has to be something like done at the protocol layer. You can't just blame the users when the protocol blows up.
Yeah. So my next question is, okay, like we have governance and tokens and votings, right? So this was also tailored towards the Athena people, right? The question was like, okay, like if there is V Athena in existence, for instance, right? And Athena is super big, right? In a utopian world, like 5 years from now, Athena is one of the most dominant stable coin. There is VE Athena. Now, who would be the and Athena lets you, the VE Athena lets you control everything about the protocol, or most of the crucial parameters. Crucial parameters as which exchange should we have a lot of liquidity, on which exchange should we open shorts, right? And then if Binance comes or like some other exchange comes and buys off a lot of VE Athena and use that against some other exchange, or use that to cause issue for the protocol, how would you do that? So like, is it a good idea to give governance, use set critical parameters using the governance and voting?
I mean, I think there should be limits on governance no matter what. TBD if token-based governance makes sense for anything at all, but it certainly shouldn't have all of the power. I think the obvious example here is if the token voters have complete power over everything that the protocol does, you can always do the thing where 51% collude to steal money from the remaining 49%, or whatever your voting threshold is set to. In this particular case, I mean, I would imagine some like pretty robust risk management system 5 years into the future where you are deploying your capital across different centralized and decentralized exchanges based on some combination of available liquidity and the current funding rates on all these different exchanges, with some assumptions on like how long it's going to take to move the capital from one place to another if you need to do it. If that was delegated to governance, then I think there's a lot of attacks that are available, not really anything too satisfying on the protocol itself. There's always weird things that happen when the protocol sort of like outgrows the base layer. So here, one example would be like if Athena represents like a very, very large portion of the open interest on a particular exchange, there can be like potentially very bad interactions that happen there, either bad for Athena or bad for the centralized exchange, or both. And so that's the type of thing where if I was a very, very cynical, large exchange with the ability to buy up the voting power, might want to consider doing something like attacking other centralized exchanges using this.
So yeah, in short, your answer is like the governance should not have access to critical protocol parts.
Yeah, I think governance should not be touching stuff like this.
Yeah, I mean, token governance hasn't really worked too well for any protocol. There are lots of, like the reality is in this space, there are maybe 1% of the actual teams who are doing token governance where it's actually decentralized. Everywhere else you go, it's like you look at the tokenomics foundation on 66% of the tokens or whatever, and then it's token voting, let's go. Or one of the VCs owns majority share. So there are very few players who do it right, and it's very hard to do it right. I think ideally what should happen is like it should be more transparent of the reality. So I really like to compare it with actual democracy, and I think like we have figured out how democracy should work more or less over time, and we can just reuse that. Like all of the token holders or whatever come together, vote once every few years or whatever, and select one like group of people that's gonna lead, and then they lead the protocol. Like the actual people, all the power they have is to change the people who are leading, not make individual day-to-day decisions. They don't have the context for that. And I think that model works very well. The team who got selected has some independence, can work and can take tough decisions and so on, because lots of these decisions are security related or things which you cannot share publicly for voting and so on. So I think it's very important to have like one like closed council, but at the end of the day, the token holders should have some say. So I think the balance is where they are allowed to select the council, and if they don't like how the council is working, they can change it.
So instead of like per vote governance, should go towards representative form of governance.
Yeah, basically.
I'm also not so good in risk. I am focused on more technical side and engineering. But I definitely agree that the protocols should be managed by token holders. And Gearbox is DAO managed protocol from day zero, because even it was deployed, people voted what we should add and what not. And of course, we should attract pretty strong players like Gauntlet or Chaos Labs in our case, which could really analyze and provide some suggestions and proposals for the DAO. But interesting facts related to Ezina, that Ezina was added to the Morpho through the maker, and maker asked to hard code, as I know correctly, to make an USDE and DAI oracle one-to-one. So basically in Morpho, we have a market with 1 billion DAI on one side and around 1 billion USD on the other side when oracle is hard-coded, which also gives some ideas that maybe it's a good sign, I don't know exactly here, but maker trusts the Ezina for such so huge amount of money, which also make it trusted from maybe our side. But it's a pretty hard to make all this simulation and risk. As I said, I'm more engineerical part, and here, of course, professionals should analyze.
That's a good point. So yeah, I think like almost come down to the end of the panel. Does anybody has any questions? I guess not. So I think that's it. Thanks for coming down and giving us insightful thoughts. Thank you.
Thank you.
Thank you, sirs.
Hey everybody, we'll be back here at the top of the hour for some more talks and to round out the day. Thank you so much, and thanks to the panelists.
very nice because you can do the funky thing. You can build it. Oh, nice. That was easy. Cool.
Sorry? Jose, yeah, over here. Yeah.
Supposed to open it.
No, not sure this works. Okay.
But can we turn this on so that
Oh, okay. So okay. That was easy. No, apparently it doesn't. Okay. Well, then it is what it is. Oh, there we go. This. Perfect. Nice.
All right, we're going to get started off with Henry Boubert. He's a lead software engineer at Mass Labs, talking about decentralized marketplaces. He's going to give a quick introduction to the protocol they are building for crypto native commerce, looking at the relay system and how it's possible to move your data. So go ahead and give a warm welcome to Henry.
Thank you. Hi. Thank you, everybody. I know it's late here. Glad you could make it. So yeah, hi, I'm Henry, lead software engineer at Mass Labs. We're a young team of 5 people who want to open up the commerce space and make cryptocurrency again. So what we are building is open source infrastructure for crypto native commerce systems. That means decentralized data structures and on-chain registries for stores and listing information, all decoupled from physical hosts. Of course, we're also building facilities for purchases. We are open but agnostic about different forms of escrow, but what we do want is to enable more direct relations between customers and merchants. We're thinking protocols, not platforms here. We want to grow this into a base layer on which other people can build their stuff on top of. And this is what we see as a public good, and this is the frame of reference we want to spread. The analogy I'm trying to invoke here is that of a farmer's market, but online. An open and public infrastructure not controlled by a central entity, but by shared beliefs and rules of everybody involved in the market. We strongly believe there's too much intermediation in the current way of doing commerce. For instance, how is it that there's next to no recourse for merchants on big platforms? A simple misunderstanding, complaints processed by some support person you don't even know, or false positive detection can easily lead to being expelled, losing your customer information and reputation in the process. Most of the time, this even happens invisibly to the customers. The other side of the coin here is how little control customers have about their own data. One might be totally fine with disclosing their purchase histories to a specific merchant to get recommendations about related products, but they shouldn't have to be. Secondly, I'm sorry. Right. Why do big marketplaces get all of this information? So just for supplying the grounds for merchants and customers, big marketplaces get a copy of everything that is said and sold on the market. And this is, we believe, a nuisance we've grown accustomed to, often without realizing the effects. Now you might be asking, cool, Henry, but how? Given the short amount of time I have today, I will only touch on two central pieces that we are currently working on without going into too much details about what else is on our roadmap, like indexing for multi-vendor marketplaces or verifiable reviews. The first piece here is a set of simple on-chain contracts, smart contracts. The EVM supplies us with great mechanisms for consensus and data availability. In our case, that means configuration and lookup mechanisms for merchants and customers, as well as being able to verify the legitimacy of the information in the stores. We extend the NFT standard since we think it's a great building block beyond art and tokens of appreciation, and it simply allows the merchant to say, hey, this is my store. They also enable user management for merchants to add other clerks, for instance, and as well they assist in Merkle-proof verification of the mentioned data structures, I mentioned in the beginning. And this brings us to the second piece I'm going to touch on today, which is our relay architecture. And this is heavily inspired by secure scuttlebutt and similar append-only log gossiping systems. And these relays replicate the information, the listing information of the stores, as well as help with facilitating purchases. The registries tie a set of relays to a store, and the merchants are free to pick a relay that somebody else hosts or hosts themselves, but nobody needs to trust them directly, since the data structures of the stores are signed and proven in a way that relays can't withhold or change information of a store without being noticed. Furthermore, this allows for data to be moved from one relay to another transparently without the risk of login. Thank you. So we have a website, mass.market. We have a Twitter handle, and we have a booth right around the corner behind this wall, basically. Come check us out. We have a survey, we have a demo, we have some stickers and other small pocket-friendly items that you can see the system working demo with. Thank you.
Thank you very much. And give us one moment, and we'll be back with Jose Paul from Quill Shield. Quill Audit. All right. So next up is Jose Paul, building Quill Shield and QuickCheck. Jose will be presenting on bolstering Web3 security across the smart contract lifecycle. Yeah, let's hear it for Jose Paul.
Hey guys, a lot of you here. So anyway, let's talk about bolstering Web3 security. I don't know how many of you guys are devs here, but I'm sure all of you guys are building in Web3. So the way we look at Web3 is that it is money Legos, right? We have figured out DeFi where, each piece adds to a new piece. We figured out restaking. Now restaking has given birth to a bunch of different protocols. So what keeps this as money Legos is the security part that comes in between. If there is no security, this just becomes Jenga. It just becomes money Jenga. You pull out one piece, the whole thing comes crashing down. So which is why Web3 security is something that is to be taken very seriously in today's environment now that we are running into trillions of dollars of market cap. So today I thought because of that, we will have a small discussion about how to stay safe within Web3 and how to ensure that your smart contracts are safe from day one till whenever you are upgrading it. If we take a look at the yearly smart contract deployments, we can see that we are on a rocket ship to the moon, right? So in 2020, we were at 16 million, and today we are at 1 billion plus smart contracts. And this is a bunch of smart contract data that I could pull from Dune. I'm sure across all the other chains, there are way more smart contracts deployed today. But if we also take a look at what has been happening, the growth in the space hasn't really correlated with the security. In 2020, we lost 500 million. In 2022, that went up 8 times, right? So when you involve large amount of money, and the money is in the code, and if the code is hackable, there will always be incentive to hack the code. So if we take a look at why these things are happening, what we can see is that out of the 1 billion smart contracts that has been deployed, I can tell you we did 1,000 plus. Maybe the bunch of other security companies out there, they've done maybe 10,000, 20,000 in total, or maybe, let's say, even 100,000. 95% of the smart contracts are not audited. And almost all smart contracts are not monitored. Now, why is this bottleneck present? Why is that things are not getting audited, right? The number of security researchers available, that is less. The scalability of it, that is questionable. There is high cost associated with things because of the lack of skilled security researchers and the scalability issues. And tool set barriers. We don't have enough number of tools which helps the scalability issue within the security. And training and awareness, it's again one of the issue that we have. We don't have enough new people coming into Web3 security to match the demand that is there today. So if we take a look at how smart contracts or when in a Web3 business, how things goes, first, somebody comes up with an idea. That idea becomes a business logic. And from that business logic, you move it into smart contract code. So this is the first stage. This is the development phase. Now, how to stay safe while you are building your smart contract? Unless you are building something groundbreaking, always use community-vetted libraries. Unless most of the applications that we see across new L2s, new L1s that are launching, is the same AMMs, the same lending and borrowing protocols. So you don't have to reinvent the wheel, but you need to use community-vetted libraries and try using as much AI-generated, pre-vetted code as possible while you're converting your business logic into smart contract code. Now, you've written some code. What happens after that? This code might have some basic vulnerabilities that AI-based audits will be able to catch. There is some static analysis, dynamic analysis that you could do on it, after which you are kind of assured that there are no basic vulnerabilities present in your smart contract code, things that we already know of, right? Reentrancy attacks, your arithmetic underflow overflows. These kind of attacks will no longer be present if you clear all your smart contract code with AI-based audits. Now, in your pre-deployment phase, you might have some crazy business logic inside your application for it to function the way it should function. So get manual audits. That is, I can't stress on this enough, AI-based audits at today's capabilities do not cover business logic or certain hidden vulnerabilities that might be present. So during the pre-deployment phase, always ensure that you're doing manual audits so that you move from smart contract code, which has no basic vulnerabilities, to basically smart contract code that has no vulnerabilities. And always get multiple audits done, because one set of auditors might not have seen something that others said. More eyes on the table are always better for things. Now, you have launched to the mainnet, then what, right? This is where most of the projects lack today. Everybody, since it's a practice for your project's tokens to get listed on an exchange, everybody ensures that you're getting one manual audit these days. But post-deployment, nobody is really monitoring what is going on. Now, how to do that, right? There are applications which allows you to monitor your smart contracts, which will ensure that some state variables which are present inside your contract, some functions that are present inside your contract, these things, there is always a on-chain monitoring happening, and when it falls below a certain threshold, certain values, you can set it up in a way that, let's say, if it's a staking contract and your most important variable is your balance, if the balance is falling below a certain threshold in a certain time stamp, in a certain time period, then there are two things that you could do. Set up alerts so that your devs go into a war room and figure out what is going on, and set up incident response, which is circuit breakers. If you set up circuit breakers, what happens is, after that point, all the transactions will stop, and you can go figure out what is happening, and only after that, once you figure out what is the issue, you can get another audit done on the fixes, maybe inform your community about what is going on, and then re-establish connection with an upgrade your contract and get it live up and running again. So smart contract, monitoring smart contracts also will allow you to stop your contract from interacting with sanctioned addresses if they are required. So all kinds of suspicious transactions will be monitored and will be alerted. So a bunch of times what we have observed is that a lot of the sanctioned, it is from the sanctioned wallets where these attacks come from or gets funded from, if you take a look at the forensics of the attacks. So our suggestion is set up monitoring for all your major smart contracts where all your balances are being held at least. Now, how do you do all this, right? We have a solution, of course. So during the development phase, you can utilize our AI-driven recommendations with the static analysis and dynamic analysis to prevent common vulnerabilities using Quill Shield. So once your development phase is completed, you can reach out to Quill Audits, our mother brand, who will do the manual audits for you. And post-deployment phase, you have to enable on-chain monitoring and set up incident response, both of which are coming up soon in Quill Shield. And there are other people in the market providing the same services. You guys should check it out if you can't wait till then. By Q4 of 2024, we will be ready with Quill Shield's post-deployment security solutions as well. So I hope you all learned something about how to stay safe with your smart contracts across its life cycle. Thank you.
Awesome. So our next speaker will be here momentarily, and yeah, just give us a few minutes to get set up.
No. Est-ce que tu as ton...
Ouais, j'ai mon deck. Parfait. Mais en fait... Ouais. Ah oui, on a le HDMI, ouais. Et la DA, ouais. Est-ce que tu auras besoin d'un micro? Ouais. Celui-là ou un comme ça? Ça serait très bien. Enfin, le portable. Le portable, je vais en chercher un. Est-ce que tu as besoin de batterie? crois, je peux mettre en window. Ça va être de la merde. Let's see. If we can just... Ok. Je laisse tester ça. Je vais chercher les... Can I put this? Okay, can I extend to one maybe? Yeah, and just the timing more than the notes.
Yeah, go ahead and try
It's more the timing. Okay, let's do it.
And then you'll need to slide one of them over. Okay.
Perfect.
Yes, yes.
Oh yeah, I should switch just the Ah oui, d'accord. Ouais, c'est inversé. Ok, should work. Yes, c'est tout. Ça, je vais le décrocher de là. Nice. Oop. Yes.
All right. So next up is Valentin Quelqueje, and he's a security researcher at Consensus Diligence, speaking about developing secure protocols, the power of simplicity and good design. He'll be offering a deep dive into the foundational principles that underpin the security of digital protocols. Give it up for Valentin.
Hi everyone. Thank you very much. I'm super happy to be here in Dubai and talk about something that I feel is very important, which is simplicity. I think this is something that we don't talk about enough. So I propose that we just start by maybe saying what simplicity is. So I just copy-pasted the definition from the Cambridge Dictionary. So what's simplicity? Well, it's the fact that something is easy to understand or do. So now you might actually ask yourself the question, why the heck this talk? So simplicity is actually critical for building robust systems. That's something we've known for a long time. And I feel that sometimes there is a misconception that cutting-edge engineering is incompatible with simplicity. And actually that's quite the opposite, I feel. So the beauty of software engineering is actually to solve complex problems with simple solutions, not the opposite. You don't believe me? Well, maybe you actually believe this guy, which said that simplicity is the ultimate sophistication. I think that's really true. So now, why simplicity in blockchain engineering? Well, simplifying means decreasing engineering time, decreasing costs, decreasing cognitive loads, both for developers and people that are going to review your code, and thus decreasing the likelihood of bug and increasing security, which is, of course, extremely important in blockchain protocols. As Einstein said, keep it simple as possible, but not simpler. So if you had to just remember one sentence from this talk, it would be stop over-engineering. That's it. But I guess we have to extend a bit. So let's see where does complexity come from. Well, there I just put a bunch of ideas. It's definitely not extensive, that I grouped in a bunch of categories. So it can come from the mindset, so the way you approach your protocol, right? The design, of course the development practices, and then external factors, such as like interaction with like other systems. Something really interesting that we observe in pretty much all software that have been developed is that the complexity naturally increases over time. So we really have to tackle this problem early. If you look at, so here I just plotted like the number of lines of code in Sol-C, so the Solidity compiler. And I think we can clearly see that like it follows an exponential trend. So actually, it goes in line with like the fact that as software age, they tend to be more complex. There are like several types of complexity. So there is actually essential complexity, which is the complexity that you can't avoid, because this is what actually brings value to your customer and your products. But at the same time, there is also other type of complexity that is detrimental to your product. And this is the complexity that we want to avoid. So you have like accidental complexity and incidental complexity. And those kind of complexity actually arise from your design decisions. And this is what we want to drastically reduce. Something interesting that, of course, complexity is observed throughout the whole engineering chain, so from design to execution. And we should try to tackle it at basically every stage. I would like to particularly focus on UX because as an engineer myself, I know that sometimes UX is really something we actually overlook. But the truth is that when you're actually building customer-facing products, UX is extremely important. So, for instance, I've been lately reviewing some wallets, and it turns out that like, if you're building a wallet, but your customers don't have access to all the information that they need, for instance, when they're signing a transaction, it's a clear red flag. And this is oftentimes a UX problem. So be mindful of your UX. And complexity is a bad loop. Because why? Because when it increases, it's harder to write good specs. It becomes harder to write good documentation. Same for the codes. Oftentimes it comes with like more interactions, more dependencies, and then the complexity increases even more. So we really have to tackle it early to break the loop. Now, if we want to optimize something, we have to have like KPIs, right? Like metrics to quantify it. It turns out that like it's quite hard to quantify complexity. So we have a bunch of objective metrics that we can use. So a number of lines of code, or like the cyclomatic code complexity, which is something that's often used in the software industry. So it's like the number of linearly independent paths in your program. But there are also subjective metrics, and I feel these subjective metrics are often like even more important. So basically, if you are building something but you can't explain the design easily to someone else, and it actually happened to me, so I know, it probably means that like your design is not simple enough or you don't fully understand it. So how to simplify? Well, again, there are a bunch of points. But I would like to focus on 2 points, mainly because I think they are the basis of everything. The first one being focus on what's relevant. That's extremely important. The second one being make simplifying your code a priority within the team. If you don't do that, you're going to end up with a complex product. So a big principle is you aren't going to need it. I feel this one is very important. So don't write code that you don't need. Actually, it sounds very simple, but when I'm reviewing code, I very frequently actually reviewing and reading code that's not even like needed in the protocol, meaning either it could be completely avoided or just like simplified by a lot. And that might be the first and most important principle. A second one is like write code that's easy to change, and more importantly, based on what you know now, because no one can predict the future. Otherwise, we would all be rich and we wouldn't work anymore. So write code based on what you need and you know now. Last, overthink, that's good, but don't over-engineer. Meaning, don't write code that is too generic. Just write codes that's generic enough for what you need right now, and maybe later you'll tweak it if you need. I like this statement from a guy, which is John Gall, and it's funny enough a doctor that focused for many years on system design and resilient design, And basically this statement summarizes the fact that like all the complex systems that work properly have actually evolved from simple systems. So you can't build, if you start building a complex system from scratch, it will probably fail at some point. So simplicity requires design, because people do not naturally build simple systems. We actually like complexity as humans. So what's a good design? Well, it's something that you can easily explain, something that you can draw and write about. If you can't draw your design, it probably means it's not that simple. It's something that do not always reinvent the wheel, but only when needed. And it's something, more importantly, that's driven by global decisions, not local decisions. So here, this is something that the NASA wrote. So they studied, they did an amazing study about flight software complexity, because of course this is mission critical. And that's what they say, engineers and scientists often don't realize the downstream complexity entailed by their local decisions. Meaning that like, you really have to think about the design and work with all the team if you want to end up with like a simple product. It's not that engineers want to build a complex product. It's just that like they're all working on their own components and just don't realize the overall complexity that like they're building together. So I guess if you can answer that question, it probably means that like you're on the right track. If you can explain to a 5-year-old children your design, it probably means it's already like quite nice from a simplicity perspective. So I just wanted to illustrate this talk with like a quick example of a not so great design. So I don't know if you know that product, but this is one of the biggest failure of like Silicon Valley. So this startup called Juicero raised like hundreds of millions of dollars to build a juicer. And it turns out that they ended up with this machine that's supposed to take a bag of veggies and just press it to make juice. It turns out that like people realized that instead of buying this $400 machine, they could just take the bag and press it with their own hands, and they would end up with the same juice. So, yeah, design is all about trade-offs. No requirements is really bad, because then you don't have a good design, but too many requirements is also bad, because you might end up with like a product that's too complex. So you have to find this thin line between the two. So here's an example, right? So if I write this requirement, an easy to clean device that efficiently extracts juice with minimal efforts, I might, as an engineer, end up with this. But now, assume I write that. I'm not going to read it because it's too long, but I end up with this, and it's a useless product. So now, what's a good design? Well, you can illustrate that with like a sticky note, for instance. This is a good product, very simple, solves a problem, helps me to remember important stuff, and it does it right. Maybe something that you're more used to, Uniswap. I think it's a good example of a great DeFi protocol. Very simple code, few contracts, clear separation between them, great documentation, just great example. Yeah, if you're building a DeFi, you should take inspiration. So write, draw, put your design on a sheet of paper, and if you cannot do it, it's probably too complex, and you can simplify. Something also really important, make sure that you perfectly, and I want to stress the perfectly, understand all the system that you interact with, otherwise you might end up in a bad loop. It's also better to safeguard than to assume, meaning that like when you interact with external systems, you should implement as many preventive measures as needed, because if an external system is compromised, you want to avoid the repercussions on your own system. And lastly, simplicity requires thinking. So there's an example, right? Finding duplicates in a sorted array. So I think this is a funny example. On the right, you have like the naive solution. just two nested for loops, order n squared complexity. And on the left, you have like a much more elegant and simple solution, which uses the ordering, natural ordering of addresses. So sometimes, let's say, the most simple solution can require a bit of creativity. I like this guy, and I think he stated like pretty much everything. So yeah, simple can be harder than complex, and you have to work to end up with like the simple solution. Make your code readable. That's of course extremely important because at some point some people are going to review your code, and we are all humans. So to do a great work, we have to exactly understand what you want to express, and it's much easier to review code that's readable. So be consistent, follow conventions. If you're doing something in one place, do it in every place. Follow the standards. It makes your code a lot more secure. This is a bad example. I don't know if you know the USDT contract, but basically their approve function is not ERC20 compliant. And a lot of devs have to actually circumvent that, and that's annoying. Write good documentation. I know no one likes to write documentation, but it is extremely, extremely important. Write comments, but good comments. Explain why you did something, not what the code is doing, what the code is doing. Everyone can infer it. Just read the code, why it's much harder. Finally, of course, we also don't like that as devs, but test your code. Unless you've tried it, you don't know that it works. And use all the tools at your disposal, meaning fuzzing engine, unit tests, symbolic execution if you want. Yeah, all the bells and whistles. And finally, if you're a cool security researcher and want to work in an amazing team of incredible security researchers, just feel free to ping me. And it will be a pleasure to connect. Thank you very much.
All right. Thank you so much. So we're going to get all of our panel speakers together real quick. I see them all in the room, I think. So just give us a few minutes to get them all seated, and we'll go ahead and get started with the security panel. All right, so coming to the stage, we have Sarang Parikh. He's advisor at SushiSwap, Mudit Gupta at Polygon, Valentin Quelcahay, you just heard from. He's from Consensus Diligence. Omar Ganyev, he's the Decurity founder, and Pratim Rao from Quill Audits. And I'll go ahead and give you my mic since it's the only one left.
Hey everyone, so yeah, we're going to talk about DeFi security and stuff. Hope during the panel nothing gets hacked, or we might have to stop and get into a war room. So yeah, let's start with some introduction. Hi, I'm Sarang. I used to do engineering at SushiSwap before. Now I just help and advise other apps.
Hey folks, I'm Mudit Gupta. I lead security and smart contracts at Polygon.
I'm Omar Ganyev. I'm CEO and co-founder of Decurity.
Hello. Okay. I'm Preetham. I'm co-founder at Quill Audits. My bad. I'm Preetham. I'm co-founder of Quill Audits. We are also a blockchain security company.
And I'm Valentin. I'm a researcher at Consensus Diligence and core member of CRIT-DAO.
Yeah, awesome. So let's get started with some questions. So one of the questions that I had, like there are a lot of attacks which happened in last year, like with Euler and like with Nomad, which happened after the audit, right? So they had a very well audited code, 6-7 times audited, flaunting on Twitter always, and they changed some code which they deployed, which got hacked, right? So what do you guys think about it? Like, should auditors have some kind of, like a dashboard or something which says that no, now this, like this code base is not audited by us anymore? Because for a user, what we see is we can't always, like no user can just directly go and check the commit hash, right? Because there might be some other changes as well. So how would you guys as an auditor, like, or in the space of security, would like to address this problem where, protocols, after they've gone through the audit, they need like some kind of checks to make sure it's the same code?
Yeah, I have something to say, I think. Well, there is one obvious problem that we don't have a common standard for sharing the audit results. So there are PDFs, there are some portals, there are markdown files, but there is no really a standard where we could share that these particular lines of code have been audited. So that's a very big problem. But I think there is another problem, because sometimes the code has been audited and it still has been exploited. For example, in the Kyberswap case, there was a bug bounty report before that, which was a similar bug similar to the one that has been exploited. So I think that whenever some new information has been gained about the security of smart contract, this changes the assumptions. Like there were like maybe 50 audits, but then there was a bug report. I think this bug report invalidates the assumptions about the security and safety of this protocol, and now we have to do another round of audit considering this new information. So this has, I'm not sure if this has been done in that case, and I think it has to be done. So this is another problem we have, I think.
Yeah, I agree. So funny enough, before working in blockchain, I've worked for some time in the banking industry, and I think this problem of like information sharing within cybersecurity is actually not something that only exists in blockchain. So it's also a problem in other industries. And I think that like in blockchain, we're already like better than like in many other industries. I think there is an open proposal about registering like audits on-chain, like having some kind of on-chain representation of audits. I don't know where exactly this proposal is standing right now. I've looked at it like a few months ago, and I think like it was really interesting, and I think it could be like one of the ways to actually solve the problem like you were talking about, right? I mean, it won't solve the problem of like bugs that still exist in the code after an audit, but actually it can at least address protocols that are updated, for instance, after an audit and users not knowing about it, right?
Makes sense.
Yeah.
I have a bit of contrary view that I believe audits should not be used as marketing material. So at the end of the day, it shouldn't matter if this has been audited or not, because no audit can guarantee 100% security. So I would rather just have like users need to trust the team to properly manage risk anyway. And if we can educate users to do that, then it's fine. Audit becomes just one part of due diligence. 99% of the code you guys or anyone is auditing is ruggable by bad parameters or governance or any other way anyway. So like the whole idea of audits being used as like a security certificate is just not good.
Interesting. For me, I think we have worked with so many clients, and I have seen so many cases like, after the like hack or anything, these protocols like always blame you as an auditor, you guys missed it, right? And while doing the investigation, we have so many cases, after the delivery of the report, these guys did some changes and not gone into some hacks, right? And this is also one main thing. And the second that we have seen is that currently there is no proper incident response team if any hack is going on, and if we feel, like just assume there was some hack was going on in some Viper language or anything, right? But there is again so much protocols using that, like just assume the Open Zeppelin library or any library, and these developers also like facing that hack, but currently they are not getting any notification. Like in Web2 world, the GitHub is sending notification, upgrade your smart contract, stop your smart contract, right? So these two systems are not currently in touch, like the monitoring part and your code is not touched. Like just if any hack happened in DeFi protocol, but there are other DeFi protocol, they should get any notification, upgrade, pause any smart contracts, and I think we need to work on this thing.
Yeah, I mean, that was my second question. Like, what is the top 0.1%? Like, what about the rest 99.9% has most of the funds, right?
Okay, I think... so what do you see, like, I was reading or was listening to one podcast last year, I think last year, around 99% of the projects is not using monitoring system, right? Or even like if some 1% is using, or they are getting the notification, or they are thinking to take any action after like 1-2 hours, right? So currently these kind of systems are missing, and I was in like talk with the quick swap guys, and they are saying we are integrating one monitoring stuff, but we are not really happy with the monitoring stuff. I was like, why you guys are not happy? We are just doing it for the marketing purpose, right? Like just assume we guys had any bug in the monitoring system, how we are going to take action. There is currently no process, like they have a proper DAO and everything, right? Like just assume the monitoring system identified any hack in the process, what's going to be, like how the DAO is going to approve, what the things are going to do, the hacker can do any suspicious thing, right? I think these kind of things are missing, and that's why these protocols are not using. But I think monitoring is so much important. Now your money is locked in smart contract, right? And we need it.
Yeah, I think it's really hard to sell monitoring to a project, because we have a monitoring product and we talk to the projects, and they always have concerns about the false positives and the reaction. It's very hard for them because it's basically their whole business can be halted by an alert, and they're not sure if that alert will be really useful. So we can see that the asset management funds, the hedge funds, and the traders see much more value in monitoring than the projects. And it's obvious because they allocate assets in multiple DeFi protocols, like 20 or 30 or 50. And so there is a very big chance that at least one of them will get hacked. And so it can bring value to them.
I mean, my question is also directed towards, let's say, peg sheet alerts, right? There have been hacks, so peg sheet tweets something, and the hack is still ongoing, right? And the team has no clue. There have been multiple examples of that. Like, I think one was Axie, right? I think they knew after a few days, right? So I do realize like false positive might be like one concerns for people, but it's still an agreeable risk, in my opinion, than like having a true positive in that case and not being able to do anything, right?
Honestly, I'll add there. I think the problem is like the teams in DeFi are still, or in crypto in general, are still very immature. The mature teams have monitoring set up already. Like, for example, most of these exchanges, Coinbase has like 200 people in their security and compliance team. And if you come on the other side, even the big DeFi protocols have nobody. Like Arbitrum, as far as I know, has nobody leading security. Like, it's one of the biggest projects out there. Polygon, we have around 10 people now. I set up the team. Optimism has one, I think. So it's still very immature. And these are like the infrastructure teams. If you go to DeFi protocols, like even the biggest ones have nobody. Lido, for example, probably the biggest by TVL, was hiring for one. I don't know if they ever closed that hire, but nobody has the right person who can make these calls. It's not that these DeFi teams don't want security and monitoring and something. They just don't have the right person who knows the value behind monitoring and so on. So I think we need to solve that first. Like, if they can get the right people in, then all of this would automatically get set up. Right now, honestly, like the biggest consumers and the most advanced monitoring stack I've seen is with a group of DJ traders, and all they do is like they monitor a protocol. As soon as they see something, they short it for just a few minutes, and then they close it. And they have been successful for it, and they have direct like monetary reason to advance their monitoring. So they are doing great. Like, they have probably the best monitoring stack I've seen, even better than our own stack. And they are gray hats in the sense, like, if the token doesn't drop in 5 minutes, then they let the team know, hey, something is wrong. Can you spread the news? Something is wrong. So to just close the position. So it's a very weird interaction, but the teams themselves need to see the value for monitoring, and then they will implement it.
Yeah, I fully agree. I think it's not an easy problem. But I think to be, let's say, take the optimistic side, it took years in Web2 also companies for Web2 companies to understand the value of security. Like, if you think about fuzzing, for instance, now like every big company is actually using it, but it took them years to actually use it, right? Because the products were not good enough, you had to build them. So I think right now, like, I mean, we're not there yet, as you mentioned, but I feel that people already are kind of starting to understand the importance of like security in depth, basically, as we call it. And so I feel it's going to take some time, but like as the products just mature, I'm thinking right now about like Tenderly, for instance, or like those kind of products that really have like, are some kind of like security products, but have like great UX too. So it makes them like really easy to use. And I feel these products are really going to help, I hope at least, to, so that like DeFi protocols slowly adopt them and kind of start to implement those systems in production. And as you mentioned, like having a monitoring system with like a proper incident response like process is not really useful. So it has to go like hand in hand. But I'm sure we're gonna get there at some point.
Yeah, that makes sense. And what do you guys think about how much of the horizon of auditing has been expanded? Because back then you had one Solidity code base on Ethereum and that's it, right? Or probably like two other chains and you just have to audit that. But now people just want thousands of millions of chains, right? And probably even devs want to go there with the same code base, but they all have something different, right? They might have some other feature that might break into the code, right? Not just that, now you have multiple languages where people code in, right? Like you have like Solidity, Viper, Fay, and like a bunch of them, right? And that might lead to more compiler bugs, right? So how do you guys look at this when you kind of audit? Do you guys have like a checklist which says, okay, this would work in this? Because in most of the audit reports, I don't see them saying that, like it works for what? Do you like, because if it works for general EVM and the team deploys it on some other EVM, most people, even though we don't have to look at audits as like the final thing, but most people do, right? Like including us half of the time. So like how do we do it? Like should auditors also include for the chains that they might have audited and the versions that they have used in this?
I think I have a quite practical point here. The recurring problem that we have seen in the EVM forks, or not even forks, but EVM implementations that have some features different from the native EVM, is that the testing toolkits don't necessarily support those features, and people have to mock them in the test code, and then over time those mocks get different from the actual implementation, and when you run tests, you see that the tests are passing, but in reality the mocks are passing, and the real code that will be deployed is different, and there are errors in that code. So this is a really pretty practical thing that I would advise looking into when you're reviewing the code base on such chain. You have to diff the mocks with the actual implementation and look carefully at the mocked precompiles in the test code.
This is why straying away from actual EVM implementation is very dangerous for these chains. Some of the features are very innocent and can be added, but some are just like not worth the risk. Example would be ETHDubai/Gnosis chain used to have callback in their transfer functions. So if you were creating default tokens on the ETHDubai chain, it will have a callback function that allows for re-entrancy bugs. And it went unnoticed for like 3 years or something, and then someone started exploiting literally everything on Gnosis chain. So like in Gnosis chain's defense, they saw an opportunity to add a feature and they added it, but they didn't think about the security complications it might cause, and the developers never knew it might be an issue, and that caused a bunch of problems. Similarly, in the early days of ZK Sync, it didn't support the native transfer function. Yes. So lots of protocols that just forked the code from Ethereum, deployed there, lost money or had their funds stuck and something like that. So if anyone is diverging from EVM in a way that might have security implications, please don't, or at least make it super clear to all of the developers that are building on it that, hey, be careful of this foot gun, you might shoot yourself.
Okay, so like talking about the same thing, now that what's hot currently, everyone is building new chains. I'm talking to everyone, they're just building a new chain, maybe this is forking the EVM. And the same scene I think we have seen back in 2021, everyone was forking the project from Ethereum to the Binance, and there was so many hacks and scams during the 2021 period, right? And even Binance, the BNB chain did that tweet, please, don't just copy paste the code and just change some variables. And those old projects, DeFi projects, was, getting hacked, right? And I think same thing is not happening, but as a developer or as an auditor, we need to understand how these chains are working, the architecture, the consensus, the compilers, everything we need to understand. Even I used to be auditor, but I'm not an auditor currently, personally, but I can see, my auditors is, the code is working fine on one chain and deploying on other chain, and they keep getting the code is not working right. So need to understand I think the architecture and compilers, how things are working. And now these chains are interconnected, as you told, right? One is running on maybe, Aptos, one is running on EVM. Need to have deep understanding.
Problem of open source software, I would say. So, as you mentioned, it's very easy to fork code without precisely understanding what it is doing. And it already caused actually many hacks because you can change a single line, but if you don't precisely understand what this line is actually doing, then of course it might create side effects that can have critical consequences. So I think that's precisely what I was saying before. When you're interacting with the protocol, reusing code, you have to make sure, developers have to make sure that they precisely understand the intention of the system, the specifications, the design, everything. And of course, there are always going to be some people that just go for an audit, deploy on another chain, and they think it's fine, but it's not. Again, we're in the same loop of it's partly a responsibility, I feel, of the user to check that proper audits have been done, etc. But yeah, I don't have a miracle solution for that for now.
Cool. So I had a couple more questions, but I think we've run out of time, so I'm just going to ask one last. In the last year, or in the current year, or whatever previous years we have had, what was your favorite smart contract exploit which happened, which you think if you would be proud if you would have done it, probably as a white hat, I hope, So what was your favorite bug that you discovered, or probably somebody in your team or somebody that you know of discovered, and you thought oh, this guy might be a genius to discover that?
Okay, I think we discovered very interesting, was not a bug, but again, as we keep saying, don't trust anyone in Web3, even your developer, right? So we was working with the one company, and initially during 2017-18, there was no import OpenZeppelin. They were just copy pasting the OpenZeppelin code, and then this one thing. What this developer was doing, after the audit report, he was just checking, changing the code in the OpenZeppelin, the transfer function, right? The logic there, and with the client just deployed the code, he raised some money, and then able to figure out there was some hack around it. The auditor, developer gone with the money. Then we did some analysis, and then we able to figure out around 15-20 projects same. So guy was a freelancer, and he did the scams with around 15-20 projects, right? So the developers is also doing these kind of hacks and scams. It's so very interesting. He gone with so much money out of it.
It's interesting. What about you?
One super interesting one was, I think last year or last to last year, Avi's Mango Market hack, because that was not just an on-chain hack. He manipulated the price on FTX, if I remember correctly, and then used that to exploit on-chain. So all of these audits that we had wouldn't have caught that bug. There was nothing wrong with the code per se. It was just the configuration and risk management that went wrong, which basically shows you need a lot more than just code audits.
I think I'd speak for many that one of the most beautiful hacks was Kyber swap hack, which was a beautifully designed arithmetic manipulation, and it was in the code, which was bug hunted, it was audited, and still someone managed to do this.
Yeah, I actually wanted to mention the same hack, but maybe to mention something different. I've recently worked on a lot of off-chain stuff, and an interesting, it wasn't hacked because we caught the bug, but you could connect the wallet basically to any website, and it would actually sign a transaction without actually prompting the user to sign it. And I feel that was kind of interesting because, yeah, the they didn't think about that edge case, funny enough. But yeah.
Yeah, that's really good. So does anybody from the audience have any specific questions? No, then I think that's it. Thanks for the panel, guys. Yeah.
Thank you.
Thank you.
Thanks, guys. Can you turn on the screen for a moment? Yeah, yeah. Here, I can hold the mic for you for a moment. You have to turn off it. You're on mirror right now.
Oh,
Yeah. Just go down here for a moment.
Yeah.
To the settings. It'll refresh in a second usually. Or no, go to display.
Where is it?
That's a good question right there. So turn off mirroring, stop mirroring. And now it's going to be the tricky part. So you need to pull the part that is going to be displayed over there. If you want, I can do it real quick.
Yeah.
And then use a mic free. Or you can also use this one if you want. Doesn't matter.
Yeah.
So if you don't want that mic for any reason, just put it down and you can use that one. All right, so next up is Abriel Zuki. She is Developer Relations Engineer over at Morph, and she's going to talk to you about how to build on top of Morph, a new EVML2 scaling solution that uses modular architecture, decentralized sequencer network, and optimistic ZK EVM. All right, welcome to the stage, Abriel.
Hi, everybody. I'm Abriel. I'm Developer Relations Engineer at Morph. So this is me. If you know me already, welcome. And then I've been building DeFi protocols as a Solidity engineer before, and now I'm working in Morph. And let's talk about what is Morph. So basically, Morph is an Ethereum layer 2 scaling solution that uses optimistic ZKVM. And our vision is basically redefine the blockchain landscape with a clear focus on the consumer application. So we are prioritizing consumer-centric innovation, focusing on the needs, on the experiences of users, ensuring that our platform is intuitive, efficient, and basically beneficial for everyday use. Then we are also focusing on transparency and trust, basically building a community grounded in openness and mutual trust. And we are backed by Dragonfly, Pantera, BitGet, Spartan, and a bunch of other venture capitals. And we are also focusing on decentralized AI protocols, which is a very early ecosystem, but pretty exciting. So as I mentioned before, we are backed by the most trustworthy crypto VCs and angel investors. We just raised 20 million in seed and fundraising for like, so basically we have $25 million in investment from the previous pre-seed round as well. So now we are going to talk about the technical features. We have a pretty solid tech stack because we are basically integrating the centralized sequencer network, and we are the first and only L2 using the centralized sequencers. We have currently 7 sequencers running on testnet, and basically what that means is the centralized sequencers are responsible for both consensus and execution of smart contract operations. The sequencer network basically orchestrates, processes, and achieves consensus on layer 2 transactions. Then we are also integrating optimistic CKVM, which is responsible for state verification. It basically utilizes a hybrid approach, blending optimistic and CK rollups. Layer 2 states are basically finalized by a significantly shorter challenge period and proved by a CK proof. We are also integrating rollup contract and breach, responsible for DA through a rollup process. So our infrastructure partners are PETH for Oracle, Switchboard, Breach for Layer 0, Orbiter Finance, Polyhedra for Data Indexer, theGraph, and RPC QuickNote. If you want to integrate with us, just let me know. So why Morph? Basically, we are giving a lot of developer incentives, which is easy access to over 30 million crypto users with solid partnerships with basically BitGet because we're partnering with them, and wallets like BitGet Wallet and Trust Wallet. We also have a venture studio, which basically implies that we are offering support for builders from hackathons to post-listing on these exchanges. And we provide incubation, investment networking, fundraising, starting from 10K, community exposure, and market presence. We have an estimate of 100 million ecosystem fund to support long-term builders. And this is what we are looking for. So if you're a builder and you want to build on Morph, this is our clear focus. So we have, in the consumer-centric apps, we have social-fi, entertainment, loyalty system points. And then the centralized AI side, we have AI games, decentralized compute, AI data, decentralized models. There's so many things to build on Morph that basically we are looking to innovate our chain with those protocols. And then any DApp that can basically surprise us, starting from DeFi protocols, NFTs, marketplaces, or any infrastructure and developer tools. So we are also giving first year 100% sequencer fee profits, and we are paying out quarterly to all of our builders. Up to 100K financial support, plus a share of 30% of total airdrop allocations. And we are giving marketing resources support for our builders with wallet collaborations, top industry connections, and a lot of support in marketing campaigns as well. Everything that's, you know, if you're building something and you want something specific, you want to expand your network, you want more, you want grants, we can build that specifically for your project. And this is our roadmap. So we launched testnet in Sepolia 2 months ago. We integrated optimistic CKVM, so we are working with CK Rollup now, and the centralized sequencers. And basically now, in a few weeks, we are integrating the new testnet. We are migrating to Holesky, and we are integrating Dencon upgrade and CKVM upgrade as well. Then we're going to launch mainnet in July, so stay tuned. We'll have Morph staking related to the centralized sequencers and our AI ecosystem support, so we're working towards that. And then afterwards, we're going to integrate native account abstraction and layer 3 support. And yeah, that's all. So basically, if you're building something related to consumer applications, decentralized AI, please let me know, reach out, and we are happy to help any builder who wants to build with us. Thank you.
We still have a bit of time. Do we have any question?
Hey, thanks for coming here. And my question is, like, how you are focusing in a developer community so that our developers focus on particular domain which you have just mentioned? Like related to AI, gaming, like how you are channelizing the idea of developers towards building particular applications?
So basically, we are trying to incentivize AI engineers to come to build on Morph, basically providing a lot of different hackathons. So now we have 3 hackathons going on, including the ETHDubai hackathon. And so we are working towards the ecosystem AI support for Q3. And I think with the integration of optimistic rollups and with the full integration of optimistic CKVM, we will definitely support decentralized AI protocols, I don't know, decentralized AI agents, everything that's on-chain related to AI will be pretty useful after the next testnet. So definitely reach out to me if you are building in AI or you just want to explore ideas, because I have a lot of different ideas for that. I'm pretty excited on the ecosystem. So yeah, I hope that responds to your question.
Any other question? No. Okay. Well, thank you very much.
Thank you.
So the next speaker hasn't arrived yet. So yeah, we have a bit of time. We'll be starting again at 5:30. Did you drop it using the Google form? So it was a link on Google form. When did you send it? This morning. split screens. And yeah, if you want to move on the stage, mic clicker. If not, you can use that mic.
We're going to start early?
Mm-hmm. Oh,
Okay.
no.
Okay,
Sorry.
no. Okay, all right. I just wanted to make sure. I didn't know.
Wait.
Yeah.
Okay, this
oh,
is.
we need to tell. Yeah, sorry. Sorry about that.
This is your guys' laptop, right?
Yeah,
because
this
mine
is
is
the-
here. Okay. Damn, I was so scared. I am.
It's Vanshika Srivastava. Okay. All right. I'll go with the first name. I can say the last name. It's just if I have to say it in front of everyone, I'll fuck it up. And this is Vanshika. Yeah. I mean your Twitter.
My real name. My Twitter is this is one.
Yeah, that's
Wait,
what-
should wear the tie.
Hello.
Can you excuse me?
Oh, yeah, sure. Yeah, okay. Nice. Awesome.
Do you want to wait until 5:30 or do you want to start now? All right, well then come down. I don't want you to stand up there the whole time. All right, everybody, we are going to get started with our last talk of the day. So this is Vanshika, and not only is this Vanshika, but that's her Twitter. So you can contact her there if you want to ask her any questions or anything. But she is the developer relations manager at Gnosis, and she's going to be introducing what Gnosis Pay is, how its underlying tech of Gnosis Pay and the components make these transactions on chain possible using crypto to POS, also talking about different modules that they are leveraging. So let's welcome our last speaker, Vanshika.
All right. Hi, everyone. Good evening. I know it's been a very tired week for everyone, even since the beginning of the entire week. But I'm here to introduce a very interesting product, and as well as, the future of Web3 payments as well. So I think my intro is pretty much done. I'm Vanshika, I'm from Gnosis, and I think some of you might have already heard about Gnosis Chain, and there has been Gnosis Safe around for a very long period of time. And today I'm going to be taking you to the whole process of what Gnosis Pay is and how do you do transactions through Gnosis Pay. So yeah, let's go ahead. So if you all remember, when Bitcoin white paper was launched, the whole idea was that it's a peer-to-peer electronic cash system. So since the beginning of Bitcoin, right, the original promise, you could say, was to kind of have a payments network to it, right? But in reality, we all know that it's not the scenario in the current moment. So Bitcoin still is a crypto, and it's very difficult to be able to use in a real-world asset system. So the current payments in the banking infrastructure is very old and inefficient if you see from a perspective of crypto, because you off-ramp, you on-ramp, there is so much of work required in that whole process. And let's talk about Binance, which a lot of people have been using for off-ramping, like you sell your crypto and you get the payment in your bank. So we recently saw that because of the compliance and some of these nations banning Binance, you cannot exactly off-ramp or on-ramp from there and get it into a bank. So it's a whole hassle altogether, right? So I'm going to take you a bit with the evolution of how card payments used to work. I think the first card that ever came was in 1950s. It's the Diners Club multi-purpose charge card. And the current present segment, if you see really, it's based on COBOL. That's a programming language, by the way, which is being currently used in a lot of payments card-related system in 2000, like this 21st century. And majorly, the challenges overall in the payment system is you have a lot of intermediaries involved. You don't really exactly need that, but a typical card payment will have around 8 to 12 intermediaries. There's like a lot of flows, like payment processor, acquirer, etc. It's inefficient. It's obviously slow, because if you do a SWIFT transfer, especially for like platforms where you are raising invoices, it takes about like 3 to 4 days to credit that, right? And obviously, the old backend system sustains using COBOL. So what is the solution now to this problem, that your banking systems are a bit old and of course not very inefficient with cryptocurrencies, right? So Gnosis Pay, in one word, if I had to explain it to you in the current moment, is you could bridge TradeFi and Web3 together. So basically, you have got your old banking payments infrastructure systems, and Gnosis Pay is the whole connection between that payments infra and the blockchain DeFi. And all these transactions, by the way, happen on-chain. So your bank will come into the picture, but it will be still very much decentralized. It is not going to be a centralized process, because Gnosis Pay is a self-custodial payment solution. You hold the funds, you have the exact power to see that what you are transferring, and all the transactions happen on-chain. So the long-standing challenges, the first one is, of course, the private key management. We've been talking about smart wallets, session keys, social recovery, wallets being hacked. So there is private key management now coming into the picture where you have social logins and you are able to derive your hacked wallet or your lost wallet. The second one is obviously complex dApp onboarding, where your account abstraction would probably come into the picture. And third one, gas fees only in native assets. So on Ethereum, you pay in ETH, right, and all other chains, you have got these native assets. But as you know, these are volatile tokens, right? But on Gnosis chain, apparently the native asset is ETHDubai. So ETHDubai is a stable coin, by the way, and that is being used for the gas fees if you're doing all these transactions. And let's talking about the regulatory acceptance and the scalability. L2s are around in the space. There are still a lot of things that we are figuring out. The Denken upgrade that happened very recently was somewhat a solution to L2s, but we are working our way towards it, right? So now this is a flow. And I wish I could show this whole transaction flow to you on the screen, but apparently I don't have a card right now because currently this card is public, it's active, the Visa card is active right now in Europe and London region. So if you are someone who holds a Europe or a London passport, UK passport, you are accepted to be able to apply for the card because there's a KYC solution involved in the process. So yeah, because I'm from India, I don't have the compliance yet ready for my nationality. So the whole flow looks like you have got this Gnosis Pay Visa card, you have a payment terminal which goes to acquirer, and then you have a card scheme by Visa. So we have our own Gnosis Pay processor who handles a lot of these things off-chain and the middle on-chain. And the Gnosis Pay account and the card is completely a Gnosis Pay safe. The most simplest way to explain is that. So it's a safe account, but with a bit of changes. And that change is you have got two modules. So that two modules are delay and rolls module. I'll give you a bit more information on what these two modules do. But Gnosis chain as an L1 is coming out to become a payments network. This is also our newest vision, the 3.0 vision of Gnosis. So all the transactions on chain would be happening on just Gnosis chain, and your Gnosis Pay safe account and the card are interlinked together. All right. So are we going to call it just any credit card or any other crypto.com card? No. This is the world's first on-chain self-custodial checking account with a debit card. So you have a pay safe account which is linked to your card, and you are the one who would decide how much would you like to spend. So you have a spending balance that you can set based on whatever your needs. So you can go for 300, 400, 500 euro. The best part is your bank comes around and be like, okay, you know what, I don't want you to do this transaction. So all the other custodial solutions that exist, they can block your account. But because this is a self-custodial solution, even if, let's say, your card doesn't work, you still have the access to your PaySafe account. So you can always withdraw the tokens. Now, we are not going to talk about what tokens right now, but let me just give you a bit of more information on the whole system. There is IBAN, there is debit card, and then there is the safe wallet, which is supporting the stable coins. There are two stable coins right now. There is GBP-E and Euro-E. All these both tokens are supported by Monerium because we use that in that backend to be able to connect with the IBAN, which is your international banking account number, right? So TradeFi is spend using card, on-ramp, off-ramp via bank transfer, and SEPA bank transfer, which is basically more around the European banking system, right? And in DeFi, you have got swaps, you interact with DeFi protocols, and most importantly, you connect with dApps. So you have a card which can now also sort of connect with other dApps. Of course, this is in still process, but the view is that you don't need to hold multiple accounts, right? And you can always have this card with you and be able to connect with the dApps across other consumer products too. So, well, this is a Gnosis Pay flow. I think I already mentioned about this. But some of our providers, so Fractal ID is the one which will be helping you out with the KYC process, Safe for the Safe account for the user, and Monerium for the card and the IBAN link-in together. So the current Gnosis Pay benefits are around, first of all, obviously, it's your self-custodial solution. So you kind of own your account. Of course, it becomes your own bank, and we are not going to be the one who would be in touch with your funds. Special perks for being early. So we are providing this OG NFT for the early users of Gnosis Pay, and access Web3 instruments. You can connect with dApps and DeFi protocols to access better yields. So I think last month we organized this hackathon, ETH Global London, where we asked people to build solutions around how you could have yield-bearing tokens on top of Gnosis Pay. So let's say if you own, let's say €200 in your Gnosis Pay account, you could earn a yield on top of it and then be able to use it in the further go. Spend globally, obviously because it's a Visa card, you have the access to be able to spend this for 80 million plus Visa merchants worldwide. So you might be right now in Dubai, but you can still spend your crypto across the world at no need of Forex card anymore. I mean, if I would have it, I would be so thrilled because I wouldn't have to get my Forex card or like convert my currency to the place I am at, right? Off-ramp and on-ramp, and of course, compliance is something that we take care of. So you don't need to worry about if it's compliant with your bank because what we do is we partner up with this local bank, you could say, for example, monovalent as in to say the name of the product, where we make sure that it's pretty much compliant for settling the transactions with Visa. So your bank is pretty much not going to, you don't have to worry about the whole part that which bank do you have right now and how would you take care of the compliance if you open up an account. Now talking about the Gnosis Pay Safe, and how is it different from a normal safe? It's these two modules which completely change the working of Gnosis Pay account. So you have a delay module and you have a rules module. Delay module is basically a module that we have put in place to kind of avoid a risk of overrunning the transaction, basically because Visa settles a transaction within 2 to 3 seconds, but because you're doing this whole process of, an IBAN is involved in there and you're off-ramping and on-ramping and making sure the transaction gets settled by the bank, goes to the Visa merchant, we require at least like 3 minutes. So for that setup, we created these, sort of a throttle for the users to access the safe and be able to do these transactions, and then that whole thing gets settled by Visa. The roles module is something that will enable the Gnosis Pay to, spend €E on behalf of the user for Visa payments. So if you have any other crypto, let's say in your Gnosis Pay account, we would not be allowed to spend that token on behalf of you for the users. So only €E or GBP is the only token that can be spent in the Visa merchants, right? Like to go through the whole process. Okay, so what's next? Well, anyways, we want to definitely bring this to mass users, and the first step would be definitely getting it on Apple Pay and Google Pay. So what if you can link your crypto debit card to Apple Pay and Google Pay? It would be awesome. So that's the first step that we are taking. Second is to support more stable coins like USDT, USDC, etc. Because right now we have EUROE and GBPE. And what we want to do is that you get the access to more stable coins that you own in the PaySafe account. Third one is obviously the rewards program that we are trying to bring in, that, for example, let's say if you're spending with your debit card, you might be able to earn certain rewards on top of it, just like you get it in any debit or credit card. So reward-based loyalty programs, etc. The current traction right now, it's around 2,800 plus cards have been ordered. There are 10,000 plus users all around the world on the wait list. And this is the total volume since the launch. It's completely crazy. Like if you see the whole timeline from December 11th onwards to April 8th, it's been awesome. We have been seeing the growth of these transactions, and even people have been using this across the world, you know, whenever they are traveling to be able to use their crypto. So yeah, as I mentioned, the current regions where Gnosis Pay is active is Europe and UK and Switzerland. And coming up next is Brazil and USA. We are trying to also get this accepted for Indian users as well. So a lot of compliance involved. But this is the official thing that I can possibly tell you, that where next Gnosis Pay is going to be. Shout out to our partners, by the way, Visa, Monowait, there is Safe, Gelato, Li5 for bridging, and Monerium as well. Gnosis Chain, because obviously all the transactions are pretty much settled on this Gnosis Chain L1, and then Fractal ID for KYC. So if you want to order your card right now, this is the QR code. You can scan or you can take a picture, or you can even join the waitlist if you'd like, if you cannot order one right now. But yeah, I'm just gonna wait for 2 seconds so that you can take a picture. Okay, awesome. And well, if you are a developer like me and you would like to learn more about Gnosis Pay, see the docs, and also learn how you can build on top of Gnosis Pay, which is something that we are working on right now. Like we are trying to work on SDKs and APIs so that businesses and developers can develop on top of Gnosis Pay and they can leverage the transactions on-chain using the whole infrastructure that we are providing for the users that you have. So you can, of course, go to the website, or you could explore the docs, which is right now on Gitbook. This is a Discord channel, by the way, if you would like to join. This is open to Gnosis Chain and also your Gnosis Pay as well, so you can join in. And if you'd like to connect with me, then this is my Telegram, my Twitter handle. I am very much active on both of these platforms. If you've got any questions around Gnosis Chain, Gnosis Pay, just don't mind to ask any of these questions. And I'm very, very happy that there are so many people who came from all around the world. And you know, this product would have been super revolutionary for the ones who are coming from different countries and they would like to spend in Dubai or any other country. So thank you so much for listening, and I hope this product sounds interesting to you. We are also part of the ETHDubai hackathon as well. So if you are building on top of Gnosis Pay, you have got some technical questions, feel free to shoot it to me. And thanks once again, and have a great evening. Yeah, thank you. Bye.
Let's give the biggest round of applause in Dubai. Yeah, come on, everybody. Because this is the last talk. This is how we're closing it out. Do we have any questions, by the way? Oh, we do have a few questions. Can you take those real quick? Yeah. By the way, best questions of ETHDubai go to this man right here. He's been asking questions. Let's give him a round of applause.
Hi, I'm Sangjun from South Korea. I would love to have that card. I would love to use that card. When do you think the Gnosis Pay will be available in Northeast Asia? Any guess?
Yeah, I mean, I cannot give the exact timeline, but we have been working with most of these, banking partners, because that's how the Visa transactions are going to be accepted in the country. So as soon as we find a good banking partner who is willing to settle the transaction on behalf of Visa and work along with them, then we would get the news to you. But yeah, you should definitely sign up for the wait list, and we'll keep you, noticed on that.
5 months and 32 days. All right, I can say that. I don't work for them. All right, another question?
Yeah, actually I'm already a happy user of this product, and I have a question. The initial owner of the Safe account, when it's initialized, it's changed, and if it's somehow compromised, it would be really good to be able to update it. And I didn't find such a possibility. Okay. It's one thing, and the second is just like a feedback. Definitely, you need to get access to this account to withdraw funds from it. But when it happens for the first time, even for someone who is like familiar with Web3, it's a bit surprising because with this transaction that happens, my original address just disappears from the list of the safe owners, and a new one, very like strange address with a lot of zeros appears instead. And yeah, it's quite questionable if it's indeed non-custodial. I realize that it is because my
safe account, right? And
yeah, it could be compromised, for example, but still accessible for me to quickly like update it.
Yeah.
And also the multi-sig thing that is available by default in a safe account isn't available for this special type of accounts. Could be also interesting to still have it just to avoid one address that can be either lost or compromised. Yeah.
Yeah, I think that feature is being implemented right now so that you can like add the signer or something like a multi-sig in the whole process. For example, if you're one of the EOA account doesn't work, then how you could do the transaction. But for the feedback part, I would love to take that note and would definitely pass it on to the team.
Thank you.
Okay.
All right, any more questions? Okay.
Hi, thank you. So if I get it right, you don't need to pay fees, right, when you use this card? I mean, crypto.
So there's only one-time fee, which is the ordering fee that you'll be paying when you order the card, and that's 30 euro. That's it. There is no other fee involved in any transactions that you do on
gas
chain.
fees, yeah.
No percent, no extra fee on the whole transaction. The only small fee that would probably get detected is for the L chain settlement, like for the Gnosis chain. But we don't keep anything from you.
Okay,
it's just
you.
the first step, yeah, that when you'll have to pay 30 euro.
Is that a hand raise or are you stretching? Okay, I think he's stretching. Anyone else? Well, this concludes ETHDubai 2024. Thank you so much. And yeah, big round of applause. See you guys all next year, guys and gals. Bye-bye.